Hello everyone and welcome to another video for Elephant VFX Patreon feed. Today we're going back to the topic of advanced photogrammetry or professional photogrammetry or photogrammetry for visual effects, whatever you want to call it. This is the fourth episode on this series. So please, if you haven't seen the previous videos, feel free to do it, okay? Today we're going to be talking about drone scanning. And remember, this is the very first slide that we had a look in this course. We already talked about cross-polarization in studio, cross-polarization outdoors, scanning PBR materials for creating really nice and high quality PBR textures. And we also talked about photometric scanning. So today we're going to be talking about drone scanning. Okay, this is the topic of today's video. I really encourage you to take a look at these videos first, because there are many things that we're not going to discuss today, because I understand that you guys should know already. Okay, so I'm not really going to be talking about the best settings that you must have for photogrammetry, or the usual shooting patterns, or what is cross-polarization, or how to bake displacement maps or normal maps or albedo maps from a high resolution mesh into a low resolution mesh. All of those things and many more we have covered already in the first 4 videos of this course or this series. So I'm going to skip all of those, okay? Because otherwise every single video that I make is going to take me like 6 hours or something. And my videos are already long enough. So please, if I talk about something and you don't really know what I'm talking about, that's because I have explained that in previous videos. I will probably remind you about these, like maybe at some point we're in reality capture and I'm gonna say something along the lines of from here, you should take over and carry on with the photogrammetry pipeline. That would imply that you know how to carry on with that photogrammetry pipeline, because I have explained those concepts before, okay, just to be clear. So if you're new to my Patreon, if this is the very first video that you're watching and you don't have previous knowledge about photogrammetry, please go back to my first 4 videos about this topic. Maybe you haven't seen my previous videos, but you already know quite a bit about photogrammetry, then you might be good, right? Because today is going to be very specific about drone scanning. And maybe that's the only thing that you actually care about, because you already know about cross-polarization, you already know about turntables for props or assets. So maybe you want to skip the first 4 videos, that's totally fine. But please only do so if you already have a good understanding of photogrammetry, okay? Cool. So drone scanning. This is actually a big topic. I believe I'm going to split this into 2 videos. So today is the first video. I assume it's going to be something between 2 and 3 hours. Okay, so I'm going to post this video when I'm done recording, and probably next month, if I can, I will publish the second video about drone scanning, and that would be the 5th video in this series. Once we're done with drone scanning, there is only a couple of different topics that we're missing here. This is the original outline that I have for this series, for this course about photogrammetry. CLI scripting, for sure, we're going to be covering this in a future video. LiDAR plus photogrammetry, I think I'm going to have to skip this video, okay? And the reason being is that, well, I was hoping that with the time I would get enough Patreons to be able to justify the costs of making such a video like LiDAR plus photogrammetry, right? Of course, I do not own a LiDAR scan myself. I would have to rent a LiDAR scan, and unfortunately, with the money that I'm getting from Patreon, I cannot really justify to rent a LiDAR scan, right? I would be losing a lot of money. So I think for now, at least, I'm gonna be skipping that video. In the future, if I get enough Patreons, if I get enough income from Patreon, I would be able to rent a LiDAR scan. But for the time being, I'm afraid we're gonna have to skip the LiDAR plus photogrammetry video. I might do some LiDAR related stuff, like maybe I can get my hands on LiDAR data, and then I can show you my process of cleaning the data and creating like production ready models and that kind of thing. That I might be able to do if I can find some LiDAR data that I can actually use, because of course I have a lot of LiDAR data, but as pretty much everything that I do is under NDA, so of course I cannot share with anyone. So let's see about that. But for now, let's say we're gonna skip in LiDAR plus photogrammetry. And with that, we'll be done with this photogrammetry course or photogrammetry series. I don't want to call it a course because it's just random videos that I'm recording once every other month. That said, this is not all about photogrammetry that is going to be on my Patreon, right? We've done photogrammetry stuff before in other videos, and we will do more photogrammetry stuff in the future for sure. But the scope of this course, or the bulk of this course, everything that I wanted to talk about in this course, in this series, I guess it's what you're seeing on the screen now. So yeah, once we're done with CLI scripting, I will be considering this series to be finished. Okay. But again, we will for sure talk way more about photogrammetry in future videos. Okay, so I'm going to skip all of these that you already know. You've seen this in previous videos, and I'm gonna go directly to today's topic, which is drone scanning. Okay, great. It's such an important video today. Okay, drone scanning is huge in visual effects, and we need to talk about a lot of concepts here. Some of the stuff that we're going to be discussing today is completely new, and some of the other topics you already know, because photogrammetry at the end of the day is a technique that the basis of the technique is always the same. Doesn't really matter if we're using a DSLR camera, if we're using drones, if we're using 360 cameras, if we're using an iPhone. It doesn't really matter. The core concepts are the same. So all of those remain the same. So we're going to be talking only about the new stuff that we haven't covered before. So again, please watch the first 3 videos in case you haven't seen them yet. This is what I want to be discussing today and in the next video. We're going to be starting with common uses of drones in visual effects. And this is something that actually I wanted to say. Photogrammetry, of course, is not only be used in visual effects, right? People working in other industries use photogrammetry quite a lot. People working in civil construction, people working in agriculture, people working as engineers, as real estate people. There are many people using photogrammetry, and they also use drones. And depending on the type of job that you're doing, you're gonna have to treat your scans in a slightly different way. So everything that I'm going to say here only applies to visual effects. If you are someone that joined my Patreon because you've seen things about photogrammetry and maybe you want to work in engineering or civil construction, or plot development or whatever, what I say here might not apply to your line of business. Just keep that in mind. I mean, I work in the entertainment industry, in the film industry. So my knowledge about scanning in general, or, well, not only scanning, but everything that I talked about in this Patreon, it's fully oriented to the entertainment industry. Okay? I just want to say that out loud because I know some people in my Patreon that don't really work in visual effects but like my content, and they think they can apply my explanations to their line of work. Just keep that in mind. Okay? Great. We use drones in visual effects for scanning, but also for surveying and also for capturing extra data. We're going to be talking about that in a minute. Okay, so this is not only about photogrammetry, it's also about capturing extra data for the production. And again, in visual effects, we use drones, but in principal photography, I mean, the people who actually are filming the movie, the final pixels in the movie, they sometimes also use drones. Well, actually, they use drones quite a lot. That is also a huge difference, right? The way that people use drones for capturing principal photography is also very different than the way that we, visual effects people in visual effects facilities, use drones. So keep that also in mind, okay? We're going to be talking very briefly about equipment. There are many drones and different hardware that we can use for visual effects droning, if you want to call it like that. We're going to be mentioning only a few things because I'm going to try to keep this in the low end. And what I mean by that is like, I'm not thinking about spending $10,000 of, like $50,000 in equipment. I want to keep it a little bit more low end, but still in the professional realm. Okay, great. Then we will be talking a little bit about software. This is also important because we are very used to, in the visual effects industry, to use software like Reality Capture or Agisoft Photoscan. And yes, we're going to be using those two packages in particular. But there are more software available in the market. And especially people working in other industries, they rarely use Agisoft and Reality Capture. They will use other type of software. I just want to mention that software because sometimes you might have to work with that kind of software. So I'm just going to mention it. Okay, we're not really going to be using it. And there are actually two types of software that we might want to use when we're drone scanning. The first one is the acquisition software. We're going to be talking about that in a minute. And then we have the processing software. So, there are two lines of software there. Another important topic here is RTK, or real-time kinematics. And if you've never used a drone for mapping or scanning, this might be a new concept for you. To be clear, I'm going to give you a brief introduction to RTK, or real-time kinematic. But we're not going to be using it in this course. I'm just going to mention it because it's extremely important, because if you work in the visual effects industry as a surveyor or wrangler, you might get asked to use real-time kinematics. So I just want to mention that to you. But again, we're not going to be using it in this course. And the only reason we're not going to be using real-time kinematic in this course is because I cannot afford it. Kind of the same thing that I mentioned before about LiDAR scanning, right? I do not own an RTK equipment. That is extra hardware that you need to use in conjunction with your drone. And same thing, I don't own it. I would have to rent it. And unfortunately, I cannot pay for it based on the income that I have from Patreon. This might change in the future as well. Why not? If that is the case, I would be really happy to make a video about real-time kinematic. I haven't even said what real-time kinematic is. Don't worry about it. We'll talk about that in a minute. Then we're going to be talking about ground control points. And again, if you're not very familiar with drone scanning, with drone mapping, you might not know how to use ground control points. I'm going to explain to you what ground control or GCP are. And we will be doing an exercise also using ground control points. I'm not gonna show you how to set up ground control points, meaning that, you know, I'm not gonna be filming myself on set using ground control points because of the same reason that I just mentioned before. It requires extra hardware. I cannot afford to rent that hardware for the Patreon, but I do have data, okay, that I scanned before. So I'm gonna be able to show you the process. The only thing that I'm not gonna be showing you is how to set up ground control points on set. After that, we're gonna be talking about georeferencing. So georeferencing is an alternative for when you cannot use or you cannot afford ground control points and RTK, real-time kinematics. And that is basically using the GPS information in your drone, doing processing of that data in a software like Reality Capture, and then get better alignment and get better data sets in general. So yeah, I'll be showing you how to do that. Right after, I want to talk a little bit about shooting patterns. We know shooting patterns already for other type of photogrammetry scanning. We mentioned a lot of those things in previous videos. So I just want to introduce new shooting patterns here in drone scanning, okay, which is slightly different. I mean, for the most part is pretty much the same, but just in case you don't know or just in case you have a hard time figuring this out, I will explain that to you very quickly. Another thing that we're going to be discussing is automated missions, or what some people also refer to as mission plans or flight missions. I mean, people use different names, but basically it is a process of automating your drone so the drone can actually do the hard work, which is flying around, taking actions like taking pictures or videos or everything, and everything is automatically done. When you're mapping or scanning an environment, especially if it's a big environment, you don't want to do the work manually. So we're going to be discussing how to do that and the way that I do it. And, you know, processing workflow, of course, like, you know, how to take the data, how to capture the data and how to take the data into a software like Reality Capture or Agisoft MetaSape, and how we can do all the processing that is needed. Again, in the processing workflow, there are many things that are exactly the same as in any other photogrammetry situation. So you should already be familiar with that from previous videos. So I'm not going to be explaining things like how do you clean up a geometry, how do you the decimation of a geometry, how do you create a good quality UV mapping, and how do you import back that clean model with nice UVs back into Reality Capture and reproject all the textures. I mean, those things that are repetitive because I explained them to you before, I'm not going to be explaining them again. I'm just going to be explaining the new stuff. And once the new stuff has been explained, I can say things like, now you need to take this model to Maya or Blender or Houdini and do your UV mapping and bring it back and do the reprojections. And you should know what I mean when I say that, okay? Great. So this is the outline of this video, or actually not this video, but this video and the next video. What I'm going to keep for the next video, it's everything related with ground control points and geo references, and I think I think a couple of other things more that are probably subtopics of this outline that I have here. Okay, great. So let's move on. So common uses of drones in visual effects. All right. Or how do we use drones for scanning and photogrammetry in visual effects? And I have examples of all of these. So let me go through these bullet points quickly, and I'll show you some, nice imagery before or after. So one of the most common uses of a drone in visual effects is turntables of large assets. Okay, turntables of large assets, and these would include, architectural elements, vehicles. Let's say you have to scan a truck, or a set piece that is huge, or a monolith, or whatever three-dimensional object that is big. A building, for example, right? Or a set piece that is maybe 3 floors of a building, and then you have to do a set extension, something like that. Well, anything that can be scanned as a turntable. So remember when we scan a shoe or sneaker in one of the videos, or I think we scan also like a fruit, or I don't really remember what we scanned before, but I show you the process of scanning turntables. But we were scanning props, we were scanning small items. The same concepts apply for drone scanning when we're doing a turntable. Okay, so kind of the same thing, right? We have, imagine a top view, we have a house, right? So this is the house from a top view. This is the plot, right? Or the terrain around the house. There is an isolated house with a nice garden and whatnot in the middle of a forest or in the middle of a mountain or whatever. We can easily, come with the drone and do a turntable and scan this house from all the angles and get a very nice scan of a large element, right? Of course, every time that we want to scan from the ground, meaning that, we would use cameras and we would use cross polarization in the way that I've showed you in previous videos. But if you have something that is quite big that you cannot scan from the ground, you would have to use something like a LiDAR scan or a drone in this case. So yeah, anything that can be photographed from every angle that is big, house, a truck, a building, a huge rock, whatever it is, we can use drones for that. And we're going to be doing a couple of exercises scanning large assets that can be scanned as a turntable. Then we also have vertical elements like facades or set pieces and whatnot. And I wrote here plus a LiDAR because sometimes we do both. We do a LiDAR scan of a facade of a building, and then we do a drone scan as well, and then we combine both. That's something that I would have loved you to show, but of course, for the reasons that I said before, that's not going to happen anytime soon. But we're going to be using a drone for that. So basically, you would have a building, right? So let's say this building is, 10 stories tall, right? So this is a pretty tall building. And, we need to scan only the facade, right? I mean, if this was a 3-dimensional building, right? If this was the entire building and we would have access to all the angles, we would be doing a turntable scan, right? But especially with buildings, they are stuck to other buildings. So most of the time we cannot do a 360. So we would be doing a vertical, what we call a vertical scan. So basically flying the drone from top to bottom and scanning the building. All right, we're going to be talking about shooting patterns a little bit later today. But yeah, that's what we consider a vertical element. A facade or a set piece, right? Sometimes same thing, you have maybe a set piece that is only like 4 or 5 stories or something, and then we would need to do a set extension digitally in the visual effects company. So we would also scan this section, and then we would be recreating that digitally. This also applies to natural elements, right? Here I wrote big environmental assets, and those would be mountains, cliffs, boulders, and these big environmental assets are usually a combination of turntables and vertical elements. Sometimes in nature, you might have a huge rock or a huge boulder or even a big mountain that is kind of isolated, so you can do a 360 around it. So then it would be the same principles as turntable. Sometimes it's something more vertical, like a cliff, right? So if we have a side view, here we have water, and then here we might have a cliff, and then here we have people, right? And we might want to scan the cliff, just the wall of the cliff. And in that case, we would use exactly the same principles as vertical elements. And sometimes we have a mountain, and that mountain, is not isolated, but it's, embedded into another mountain and something more complex. And then we might combine both. We can combine a turntable that starts in this side of the mountain and goes all the way here. We cannot do a full 360, right? But we might be able to do, let's say, like 200 degrees or 220, something like that. And then we can combine that with a vertical scan, so we can scan the face of the mountain very well. So big environmental assets usually take more time because of that, because most likely we need to do like 2 or 3 passes combining different methods. All right, great. Another very common use, and probably one of the type of assets that we cover the most, is terrains and vast areas. Those are also extremely common, and that is when we need to cover a huge chunk of terrain that we need to recreate digitally in one way or another. I don't know, just to give you a classic example, imagine that there is a huge battlefield. Have you guys seen Napoleon? Well, if you guys have seen Napoleon, there is this is a top view, right? So this would be a huge terrain. You would have here like hundreds or even thousands of soldiers. Same thing here, right? And then you need to do things like explosions and digidoubles and whatnot in visual effects. So you want to scan this whole plot, this whole terrain. And that might be 500 meters by 500 meters, or it might be like 2 kilometers by 2 kilometers. It depends on the shot, the production, the sequence, and everything, right? So that is also something that we do. This is what it takes the most to scan. Doing like 500 by 500 meters, it might easily take you like 3 hours to do the scan. And I have also exercises that showcase all of these. Okay, I'll show you how to plan the missions, how to plan the drone to fly automatically to scan that type of environment, and then I will show you how to process it and whatnot. Okay, great. We also use the drones in visual effects for location scouting. This is also very important. Sometimes in pre-production or even before pre-production, you might get sent to a location that potentially could be a location for a movie or a TV show, and your task can be to just scout the place. And that is usually divided in 2 different sections. One is just flying freely the drone around to capture the scenery, to capture the environment, to actually get an idea of how the environment looks like. And another task might be to kind of shoot something that might relate to how the final shot is going to look like, right? So you kind of have an overview of the entire environment, and then you have shots that kind of resembles what the director might do later with different camera, different equipment or whatever. But you are there, you can do it with the drone, or you can do it also with DSLRs, or well, even with a film camera. But you know, when you're scouting, especially in remote locations, you probably are traveling light, so you might have only the drone and a you know, mirrorless camera or something. We're gonna be talking about this a little bit later today as well. Then we use the drone also to do quick scans, right? And LiDAR alternative. What is this? Well, imagine that in pre-production, kind of the same thing, right? You know that there is going to be a battle here in the movie, and here in the middle there is a huge rock, for example, right? And the production might ask you to go to this location by yourself, you know, not when the movie is actually being filmed, not when the principal photography is happening. No, before, maybe 4 months in advance, you go there, and you know, it's only used as a cheap trip to the location. It's not 300 people. And they might ask you, well, we are working on the previs, or we're working on the tech piece, or we just want to concept the editing of the movie. So we actually need the environment, and we need this rock here. So instead of spending, I don't know, 4 hours scanning the environment and 2 hours scanning that big rock, I might say, okay, this is only for previs, this is only for tech piece. They need something that is grounded, something that is based on reality, but it doesn't need all the detail. And I don't have the time because I only have 1 day to go there, or whatever, or a few hours. I will go there and I will do a very quick scan. And that quick scan will provide me with all the information needed for the production, but it won't be used as a final thing in the movie, right? And also I put here LiDAR alternative, or the next bullet point is placeholder for LiDAR. And this is because kind of the same thing, right? I know that at some point a LiDAR operator is going to come to this set and is going to scan with a terrestrial LiDAR this mountain in the middle, or this huge rock or boulder in the middle. But for now, we only need something to use in the previous, to use in the tech biz, to use in the work in progress editing or whatever. So I might come here with my drone, scan this thing, this rock, maybe with only 50 photos. I get a decent model, but not something that is perfect, knowing that later someone is going to come with a terrestrial LiDAR and do a really high resolution scan of this rock. Okay, so this is something that you need to keep in mind, that if you get tasked with scanning something, you need to know what is the goal of that scan, what is the final usage of that scan, because of course I want to be effective, I want to be as quick as possible, and I want to deliver the best material as possible, but always based on a context. So if I know I need a high resolution scan of this rock, I might spend 4 hours there scanning. If I need a previous version of this rock, I just want to spend like 20 minutes, because most likely I'm going to have to do all this stuff as well, right? So keep that in mind. And then we also use drones for augmenting commercial LiDAR. This is also very important, and we do this all the time. So as you probably know, there is commercial LiDAR available in the market, right? This depends on the country. Not all the countries have LiDARs available. I would say that all the countries, at least all the developed countries, as far as I understand, have a database of their country, you know, the landscape of their countries. Some of them have that LiDAR available online, so you can actually download it for free, because at the end of the day is, you know, taxpayers are actually paying for that. So some countries offer that for free. Some countries offer the data paying some amount of money. And some of the countries don't have the LiDAR available. They have it somewhere, but it's not available for the public. So you need to request it. All right. So to give you a couple of examples, I'm from Spain. Spain has a huge database of LiDARs, of, all the orography of the country. So, you can basically go to any part of Spain. You can go to this website, which is part of the government, I guess, and you can search for locations, and then it will show you all the LiDARs that are available for that location, and you can download it for free. There are some disclaimers, like you cannot use this for this, and that. I mean, of course, right? They own the materials, so they say, well, if you want to use this commercially, you need to get in touch with us, and then we can probably talk about it. But there are some limitations, but all the data is there, so you can download it and you can use it. It's great, actually. It's very good quality. That is in Spain, but I live in Sweden, right? And in Sweden, the LiDARs are not available because I think it belongs to the military or something, or I mean, I don't know what the deal is, but the LiDARs are not available. It tells you that there is a website where you can actually see where the data is available, and you see, oh, this area that I'm interested in actually has some LiDAR available. But then you need to get in touch with the government and say, hey, I saw that you have this data available and I want to use it. How can I proceed? And they will tell you how to proceed. You actually have to pay for it. We bought some LiDAR data and we actually had to pay for it. But basically, you need clearance first, right? So you first need to explain who you are, what do you want to use the LiDAR for, and that kind of thing. And they will say, yeah, we can sell it to you. Then you buy it and then you use it. So depending on where you live or where you're shooting, you might have different type of LiDAR available. Anyway, this was a long explanation, and I don't know why I said all these things. Anyway, what I was trying to say is sometimes you get that LiDAR, and most of these countries have what we call aerial LiDAR. So basically, imagine that they want to cover a range of 500 by 500 kilometers. So they would have planes flying over mountains or different landscapes, scanning, and that's pretty good. But imagine that you are doing a shot where you have one character that is walking around, and you need to see that environment from the character point of view. That aerial LiDAR is not going to have enough resolution. It might be good for the background or the midground, the mountains and all the landscape that is, let's say, 200 meters away from the character. But what about the inner circle, right? What about the 200 meters around the character? Not after that. Well, those LiDARs are not going to have enough resolution. So what you want to do in that case is go to the location and do a terrestrial LiDAR. And if you don't have available a terrestrial LiDAR, you can do a drone scan. And then you can combine your drone scan and the commercial LiDAR provided by that country where you're shooting on. Okay? So it's a combination of both. And imagine just that, right? From a top view, imagine that this is a big landscape. So this all would come from a commercial LiDAR, but then the action that you are actually interested on happens here. So all of this would be the commercial LiDAR, and all of this would be your own drone scan, which of course would have more resolution than all this big chunk of data. Yep. Great. So let's move on. These are just some examples of everything that I mentioned before. So this would be a good example of a turntable of a large asset. This is just a quick drone scan. I think it has 50 photos or something, so not that many. So of course here you need to think about what is the goal of this scan. Because if what you want to achieve is a super high resolution scan, this wouldn't do it, right? You would want to come here, with your camera and actually scan everything properly. So you would get like 2,000 photos of this car, and another 2,000 photos of this car and whatnot, and then you would get a very, very high resolution scan of each of these cars. But imagine that the task here is, let's say you're working on a shot or a sequence, and in one of the shots you have an apocalyptic city or something, and you need to see a motorway in the background with hundreds of kind of semi-destroyed cars that have been laying around for 15 years or something. So you can go to one of these places and just do a quick scan, and this will take you like 15 minutes, and you will get like 1, 2, 3, 4, 5, 6 cars that, you know, you can process quickly. You can go to another place and maybe scan another 6 cars, another 6 cars. So in one day, you might get like 100 cars or something. And then you can stick them in your shot in the background, in the motorway, cover them with dirt and ivy and whatnot. And that's it. That's all you need. So always keep in mind what is the end goal of your scan. For that purpose, this scan is just fine. Right? It is just perfect. It just needs a little bit of cleanup in some occluded areas, but for the most part, it works very, 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 very fine, right? And again, this is like 50 images. It took like 10 or 15 minutes, and you're done. All right. So this is an example of a turntable of large asset. This is an example of a vertical element. And actually here you can see the shooting pattern. Like all of this is a drone position taking a photo, right? You can see all the captures here from UGCS. We're going to be talking about that later. So what the only thing that I care about here is the facade of this building, right? So this building is connected to another building there, another building there. And the only thing that I want to scan is the facade, because later maybe I want to use this for camera projections and maybe add some dirt and ivy and maybe some damage on the facade, or maybe just want to do like a, you know, like a set extension and add something on top. So yeah, this is an example of vertical elements. Again, imagine if instead of being an architectural element, this would be like a natural element. Let's say this is a cliff, for example. It would be the same shooting pattern and the same workflow and procedures. Like this one, right? This is also a vertical element. So what I'm interested about here is the actual cliff. So kind of the same thing. Right, we're just flying the drone vertically up and down to scan this element. And as you can see, we get the very, very nice 3D models and textures. From here, these two, you can actually create an asset, a 3-dimensional asset, or you can also create tileable textures. I show you how to do that in, I think, the previous video or the one before that. So here, you know, you can extract all of these as a texture, and then you can use it in any given geometry, or you can even extract like different tileables that you can use to create your own assets. This is a big environmental asset. I think we're going to be looking at this data set later. Kind of the same thing, right? This is one of those assets that I said before that we combine multiple techniques. So here we cannot do a 360, a completely 360, but we can do something like 200 degrees or something. So, you know, we can fly different heights here, scanning this big mountain, and then we can do also vertical passes to scan it this way, okay? And again, always keep in mind what is the goal. If I need to use this mountain as a background element or midground element, it is great, right? The only thing I need to do is to scan this as a turntable and as a vertical element. That's great. But if the action is happening down here, of course, this scan wouldn't hold up, right? You would need to go here to this location and scan this in high resolution. Okay, great. Terrain and vast areas. Well, as you can see, this scan is also huge, right? I mean, a person would be like that dot. So this is a huge scan. Also, you have to work with these vast assets. This is covering quite a lot. This scan, of course, takes hours. And then when you start processing this, you will end up with hundreds of millions of polygons. So, we will see how to handle all this data later. But it's a pretty good scan, right? I mean, the only bad thing here is actually the baked lighting, because of course you are always scanning outside. You cannot use cross polarization with a drone for obvious reasons, right? You can polarize the lens of the drone, but you cannot put a polarizing filter on the sun or in the sky. So of course you cannot do cross polarization. So if you can, always scan in a cloudy day, but of course it's not always possible. Same thing here, right? We might have a shot where there is an earthquake or there is some kind of explosion in this place, so we need some kind of scan to use in our shot. As you can see, this is pretty good scan for a huge area, right? So yeah, another very interesting topic. Same here. This is also another terrain and vast area example. Of course, way smaller than the previous one, but still kind of the same thing, right? You might have a shot where there is a car chasing another car through this road, and when they come here, one of the cars actually hits this house, and everything explodes or whatever. So you need to plot the environment, right? You need good scans, and you need something that we can use later for visual effects creation. So as you can see, this is pretty good. Of course, all this area is not very good, and all this area is not very good, and that's because it wasn't covered in the scan, right? So the scan was basically meant to be doing this, all right? So this is basically stuff that came for free because the drone was actually seeing that, but the only thing that I care about here was actually the road and this thing in the middle and the houses, all right? Great. Location scouting, right? I mentioned this before. So this is a place where I was scouting. I think this is actually video. So let's play it in the background. So this is usually what I do when I'm scouting. So this industrial place here is actually what I care about. But what I do is an overview of the entire environment. So I just fly my drone freely around the environment, so whoever in the production director, the production designer, VFX supervisor, whoever actually sees the environment and they can judge if this is the right environment, so they can see it from every angle. Also, I see the surroundings, and that is important because you see things like this road and the motorway and how you can access to the location. That is very valuable information for the production, because at some point you're going to have to come here and shoot, and maybe you need 100 crew members. So where do you park the trucks and the vans and all the stuff that we need? So all of that gives you information, right? And then of course I focus on the actual subject as I'm doing here. And if I place the videos, you can see I'm kind of scouting this from every single area, from every single point of view. So this might give the director like oh, maybe this looks very cool, maybe we can do like a shot that comes from the top or whatever, and then every single detail from the top, from the bottom, I can see everything here, right? And again, this is not a scan. This is not meant to be used for creating a 3D model. This is just for scouting. But it is one of the tasks that you might get asked to do when you work in visual effects. And then what I'm trying to do also is like, shots that I know that maybe the director wants to do. Maybe, I had a chat with the director, and the director said, well, based on the pictures that I've seen online or Google Maps, I thought it would look nice if I shoot something from here, having this in the background. So I might go there with the drone and do some kind of shots that resemble what the director had in mind, right? Anyway, just get as much detail as possible. One important thing when you're doing drone scanning, again, you're gonna have to do probably two passes. The first pass is an overview of the thing, and another one, it might be recreating the shots that might end up in the movie in a way or another, or might resemble something that ends up in the movie later. So keep in mind that for those, not for the first one, not for the overview, but for the shots that you're doing with the drone, you might have to track those shots. Okay, you might have to do some camera tracking. So imagine here, right, that the shot is going to be something like this, and we're going to be maybe panning down or something. And maybe in this area, we need to add in CG some kind of, I don't know, like a train with some train tracks or whatever element you might think of. Maybe we need to do this, this shot, and maybe the production department or the assets department, they are already, oh, this is another one. Okay, let's use this an example. Let's say we have this shot and all of this is an assembly line with, robots and whatnot. And maybe those are already in progress. Maybe the assets department have built those already, or maybe the production department from the client side have modeled those already. So you might get asked to actually track this shot. So I can track this. Okay, so I track all this movement, and then I can add all the robots in CGI here and then present this to the director and see, hey, look, this location looks actually pretty good. You see the real environment, and you see all the robots here and everything lit and everything, even if it's not final, it's not a shot for the movie. We're still in pre-production, but you can show the director that, everything in context and everything works. And then the director might say, oh yeah, this is actually working. This is not the shot that I want. I want to shoot this completely different, but the environment looks nice. The integration with the CG, all the robots and all of that looks nice. Everything fits into the same environment. So yeah, let's go to this place. That is the goal of this drone scanning task, or drone scouting task, I would say. All right, but yeah, I use this a lot. Also because it gives me like when I'm scouting with the drones, what I want to do mostly is staging. Right, so maybe this is never gonna be a shot in the final movie, but it would be a good story as a staging, right? Like, okay, what is this place? Okay, this place is this abandoned factory, but maybe there are some kind of mafia bosses that are building AI robots that will, I don't know, join like a gang crime thing with robots. I don't know. I'm just making things up. But yeah, it will give you a lot of information. So yeah, I use these quite a lot. And of course, as I said before, I do exteriors, I do interiors. I try to always show like an overview of the entire environment. So, maybe the director was thinking only about the interior, but now they have information, the production people, they have information about the exterior as well. And they might say, oh, actually, we can do whatever in the exterior. So yeah, anyway, this is me doing location scouting. All right. Another thing that we mentioned before is that we also do placeholders for LiDARs, and this is one of the examples. This is actually only 50 or 47, I believe, 47 image, believe it or not, and the scan is pretty good, right? So imagine that this is a shot, and again, we're in pre-production, and there is a spaceship that maybe, is going to land here. So this is, like a huge spaceship or something. Nice spaceship. All right, so this is a spaceship or a chicken that is going to land here. and we're in pre-production, and you know, we know we're gonna come here 3 months later and do like a proper LiDAR scan of this rocky mountain, that rocky mountain, another terrestrial LiDAR of all this environment here. But again, we're in pre-production 3-6 months before the principal photography, and we ask ourselves, or the production ask me, is this the right place to do the landing of that spaceship? Let's go there, let's scan this as quick as possible, send it back, process a quick model, and we will use this in the previs or the TechVis, and that will give us information. So I go here, I scan this in half an hour, send it back, and they have it. You know, it's a cheap trip, it's just one person capturing the data for 1 hour, and we're done, and that will save a lot of time and money later. So this happens all the time. And again, this is not super high quality, but it is good enough for what we want to use it at this point of the production. Okay, a placeholder for LiDAR. And this is what I was mentioning before. This is augmenting a commercial LiDAR. So you can see it here very clear, right? This is a LiDAR scan provided by a government, like what I was mentioning before, something you can find online. It is actually pretty good, believe it or not. But, you know, if you have a camera here and you're looking there and you have this mountain in the background, this LiDAR is pretty good. Also, you can appraise it a little bit, right? You can run it through a terrain system or something to add a little bit of detail, even though I don't recommend that because you are kind of modifying something that is already real because it's the real world. But anyway, and by the way, this is just a screen grab from Houdini's viewport. Okay, so this would be much better if you render it and light it and you do the scattering and all that, but you know. But anyway, this is looking great as a background, but my action is happening here. And that detail is not good enough for ground level shots. So what I've done, I come to this location and I drone scan this small area. Well, actually it's not that small. You know, again, a person would be like that dot here. That is a person, right? So yeah, I just go there, I drone scan this section that I care about because that is my foreground, and then I combine that foreground with the background that was provided by the commercial LiDAR company. So when I go here you can actually see the difference between this, which is the commercial LiDAR, and this, which is my drone scan, which is of course much more high resolution. Right? So here you can see that all this is my drone scan and this is my mountain in the background, which is, I think is this peak here. We don't see that one because this one covers it in this camera, so it would be behind. So yeah, this is basically what I have. So combining both, I will get a really, really good result. And again, this is just a screen grab from the viewport. If you see a render of this, it will look extremely photorealistic, right? And this in the background would have like, you know, nice textures and scatters and whatnot. Okay, so we're done with all the use cases for drones in visual effects. So let's talk now quickly about equipment. Okay, so let's continue where we stopped last time. Let me maximize this again. There you go. And let's carry on talking about photogrammetry. So when it comes to hardware or drone equipment, I just made this very simple, right? Because I'm not talking about the whole variety of drones that we have available in the market. I'm just talking about the most used drones, I would say, or the ones that I've seen being used the most. Always in the context of visual effects, right? There are many other drones, especially when we talk about principal photography. There are a lot of custom-made drones and whatnot, and very high-end, expensive drones. I'm not talking about those. I'm just talking about consumer-level drones, the drones that everyone can buy. Of course, there are different ranges of those drones with different capabilities, different budget, and whatnot. So let's talk quickly about that. The most important thing is, I guess, these things here, right? This is what you want to look for when you're getting yourself a drone, either if you're buying a drone or renting a drone. It doesn't really matter. One thing that you should consider is the camera quality, right? You want a camera that is good enough, it has enough resolution, it has enough dynamic range, it can shoot ideally raw images and videos. That's a little bit more complicated. Most of the commercial drones do not shoot raw footage when it comes to videos. But again, for scanning, most of the time we're using photos. We're not using video, so that's fine. Another thing that is extremely important, aside from the camera itself, it's the wind resistance of your drone. Keep in mind that the most expensive commercial drones, they are really good when it comes to wind resistance. And then you have other drones that are cheaper, but they also have a pretty good camera, especially if you compare like the high-end commercial drones with the medium range. The difference in camera quality is not that big, but wind resistance, that might be like a huge gap between a medium range drone and a high-end drone. So keep that in mind. And wind resistance is very important because, especially when working in visual effects, you're going to be shooting in remote locations. So it just happened to me that I've been shooting a lot in mountains at high altitude, like 1,500 to 2,000 meters high. And in those locations, usually the wind is very strong, or it can be very strong, and it also changes so quickly during the day. So you might be shooting and everything is great, and all of a sudden it's super windy, and maybe 20 minutes later it's not windy anymore. So you need a drone that is capable of fighting the wind. Some medium range drones, they cannot even fly when it's windy. The drone sensors will detect that the wind is very strong, and it will decide not to fly. So, it wouldn't take off. No, actually, it will take off, but it wouldn't let you move the drone, let's say, higher than 10 meters or something. And it would say it's, the conditions are so bad, so the drone cannot fly. With better drones, you can actually fight the wind a little bit better. Of course, if it's extremely windy, if it's like a huge storm or something, you're not going to be able to do anything really. But yeah, if it's windy, but it is not terrible, with a high-end drone, commercial high-end drone, you can actually keep working. Okay, so it is important to have a drone that is capable of fighting wind. Another thing that is important is battery life. And most commercial drones, the battery life is quite good. It's something between half an hour and 45 minutes, which is pretty good. Of course, if you're using a drone for professional VFX tasks, of course you're going to need multiple batteries. So one battery, of course, is not going to do it. You're going to need, I would say, something around 10 batteries for each drone in order to be able to work efficiently while surveying for visual effects. Then we have the SDK, and this is extremely important. So the SDK, it's basically a piece of software released by the company that makes the drone, that makes the hardware. So other third-party companies can actually access via software to the hardware. That is extremely important because most of the time you're going to be using third-party apps to program your mission flights. Everything that you can automate in a drone, you want to automate. That is extremely important. If the SDK of a drone is not published by the company that makes the drone, then third-party apps cannot access to the hardware. And that is extremely important because, again, everything that we do photogrammetry, or 80% or 85% of what we do it with automatic mission plans. So that is extremely important. And not all the drones have the SDK available. We're going to talk about that right now in a minute. Portability. Portability is also very important because, again, sometimes you need to work in remote locations, so you might not be able to access to those locations by car. And this is especially important in pre-production because maybe in production, in principal photography, you would be able to access by car because, some kind of path or road might be developed for the film crew that need to get to these places by car, by trucks, by vans, whatnot. But in pre-production, most likely you're not going to be able to access by car to these remote areas. So of course you need to fit your drone in a backpack and you need to hike for potentially a long time. So it is important that your drone is not a huge monster that doesn't fit anywhere and is very hard to carry around. And then modularity. And what I mean by this is like you can put accessories in your drones. So you want a drone that, of course, you can replace the propellers when they break. If your gimbal breaks, you want to make sure that you can change the gimbal or any other part that is important, because if you're spending, let's say, like $7,000 on a drone and you break something, you want to make sure that you can change that part that you broke, and you don't need to change. You don't need to buy a new drone. And also for important kits like this thing that we see here, which is an RTK kit, and we're going to be talking about RTK in the next few slides. All right, so these are the drones that I can recommend to you because I've used them and I know very well. So when it comes to budget level, so this is, in my opinion, the cheapest good drone that you can buy is the DJI Mavic Mini 3. I think there is already a DJI Mavic Mini 4. I'm not sure. I believe so. I have a DJI Mavic Mini 3 and it's great because it's pretty good. I mean, the camera is pretty much the same as the DJI Mavic 3 Pro. The thing that is not that good is the wind resistance, right? So I can do things with a DJI Mavic 3 Pro that I cannot do with a DJI Mavic Mini 3. But it's a pretty good drone for, I don't remember how much it costs, but when I bought mine, it was less than 1,000 euros. But again, I don't know right now. It's probably way cheaper, and probably the DJI Mavic Mini 4 is probably around $1,000 or euros. I don't know, but it's something around those lines. And it's pretty good. I really recommend it to you. What I'm not sure about the Mavic Mini 4 is that they have released the SDK for that drone. For the Mavic Mini 3, it took like a year and a half or so for DJI to release the SDK. So I would not be surprised if the DJI Mavic 4 doesn't have an SDK published yet. So keep that in mind. When it comes to medium level, there are a bunch of them. The one that I would recommend to you 100%, even above the advanced drones, is this one here, the DJI Mavic 3 Enterprise, which is actually this one that you can see in this image. This is, in my opinion, the best consumer drone. It has a great camera, it has really good wind resistance, the battery life is great, it's about 40 to 45 minutes. It has an SDK, which is extremely important because then you can use third-party apps to program your flights. It's portable, you can have, it's modular, right? Like this one, for example, has the RTK, as you can see here. It's great. In my opinion, it's the best drone out there. It is not cheap. I think if you get the the best combo that comes with the RTK module and everything costs something around $7,000 to $8,000, I believe. But it is the best. Okay, it is the best. No question asked. If I have to buy a new drone, this is the one that I'm buying. I do not own a DJI Mavic 3 Enterprise, but I rented it before, and in my opinion, it's just the best drone for visual effects work. Then there is the DJI Air 2S, which is cheaper, but it also ticks all the boxes here. So I would also recommend a DJI Air 2S. Then the DJI Mavic Pro, this one here, DJI Mavic 3 Pro. This is the one that I have. I actually have two DJI Mavic 3 Pro, and I have one DJI Mavic Mini 3, and I also have a DJI Mavic 2 Pro. So I have the 3 and the 2. The 2, well, or like almost 2 years ago, like a year and 8 months ago or something, I needed to buy two drones, and the Mavic 3 Pro was released like 2 years ago or something, right? So that's the one that I bought. The DJI Mavic 3 Enterprise wasn't released yet, so this one wasn't out yet. So I bought this one thinking this would be, you know, a better version of the Mavic 2 Pro that I had before. And it is, right? It is kind of an evolution of the Mavic 2. It's great. It has a great camera quality, great battery life, great wind resistance, and everything that we mentioned before. But as I wrote here, it doesn't have an SDK yet, which is terrible because I cannot program the drone automatically. There is a way of hacking that, you know, between quote marks, right? It's not really hacking, but there is a way of solving this situation. But there is only one software available to do that, and it is not the best solution. And actually, I'm going to show it to you how to use that software to actually program flight plans in your DJI Mavic 3 Pro. But I would not recommend to you to buy a DJI Mavic 3 Pro now, because again, there is no SDK for it. I would recommend instead to buy a Mavic 2 Pro. Even if it's older, it's still a pretty damn good drone. The downside is like the Mavic 2 Pro is not in stock anymore. But you can still find them in some stores, like, you know, they have it in stock for a long time. You can find it there, or you can buy it secondhand, which is also a pretty good alternative, and you can also save a little bit of money. But if you have the budget, again, this is the one to go. Then you have these other two drones. These are not made by DJI. It's the Evo 2 Pro version 3 and the Skydio 2 Plus. And all of these cover, you know, tick all these boxes. So they are also pretty good. I prefer DJI, especially because it's easier to find them anywhere in the world. You know, pretty much any country you can find them. You can find the spare parts. They have a really good customer service and all of that. But these two are two very capable drones, and you will see a lot of people using them as well. And then you have more advanced commercial drones, and these are the Inspire 3, the Evo 2 Pro 6K RTK, the DJI Matrix 350 RTK, and of course you would have custom drones that some people build or some companies build for you based on your requirements. All of these, you know, even though they are consumer drones, well, maybe not custom drones, that's kind of customized, but all of these, even though they are custom drones, they are way more expensive, but they are also great. They are bigger, so, you know, when it comes to portability, they are not that great. But, you know, if you can get your hands on one of these, or at least if you can rent it to test them, you will see that they are great alternatives as well. But even these are more advanced and more expensive drones, I would recommend 100% the DJI Mavic 3 Enterprise. This is the drone that you should get, if you have the budget, of course, to work in visual effects. Otherwise, again, I would go to Mavic 2 Pro or the DJI Air 2S. And I really hope that DJI releases the SDK for the Mavic 3 Pro, because it's a great drone. I have 2 of them and I want to use them more. And again, I have this hack to kind of program missions automatically that I'm going to show you later, but it's not, it's not the best thing. All right, so this is everything that I want to say about hardware, about drones. This is the equipment that I'm going to use for this course, for this video. So I'm going to use my DJI Mavic 3 Pro, which is this guy here. I prefer to use the classic controller with an iPhone that, you put this iPhone here. There are other controllers that might be, well, I wouldn't say better, but they look cooler because, they have a screen in the controller and they look much sci-fi and whatever. I actually prefer this one because the battery lasts longer because it doesn't have a screen. You use your iPhone. So I actually prefer this one. I have 7 batteries here actually. So I have 1, 2, 3, 4, 5, one that is inside and I have another one on the side. So I have 7 batteries for this drone. I have more because I have 2 drones. So, I could use more, but in these trips that I'm doing to capture footage for this course, I'm actually taking 7 batteries with me. And, each of these batteries, it's I can fly the drone for about 40 minutes. And that, of course, depends on the weather situation as well, right? If the wind is very strong, your battery is going to die faster because it needs to use more power and it's going to take less time for the battery to die out. Also, if you're flying the drone automatically, the batteries will last more time. Because, when everything is automatic, you are not doing like fast movements, you're not braking. It's kind of like the car, right? When you go to if you are driving through the motorway and you're always at constant speed, you spend less gas than if you are accelerating, braking, kind of the same thing with the drone. I usually have like 3 SD cards, micro SD cards with me, and I usually also have a reader. That's very important because, in my case, my laptop here, which is a MacBook Air, doesn't have a card reader, so I basically use this thing, and I always have my laptop and a hard drive with me. One thing that I do every single time that I land the drone to change the battery or to do whatever I want to do, I always download the photos and make a backup in my laptop and my external hard drive. And the reason being is that, imagine that you have a very large micro SD memory card and you are flying the drone for 5 hours and collecting a lot of data. And at the end of the day, you crash the drone into a cliff, the cliff goes into the water and the drone is gone forever. Well, that's a bummer. You need to buy a new drone, but also you've lost all your footage. So that is even worse. So every time that I land the drone, I download the photos. So if I crash the drone or if I lose the drone in the middle of the forest or whatever, at least I have the footage, right? And also something worth saying, you should get an insurance for your drone, right? Of course, this depends on your country, but most countries require some kind of pilot license. For these commercial drones that don't weigh a lot, the pilot license is very easy to obtain. You just need to study PDF with some information. Then you need to pass an exam. You can do everything online, right? So you can actually, if you're not sure, you can actually check the book and check for the answers. Everything is kind of common sense, right? There is nothing complicated there. It's mostly about security. Don't fly around buildings, don't fly around people, that kind of thing. But you need to read a book, which is a very thin book. You need to pass an exam, and then you need to get your license and pay like an annual fee. In my case, I think I'm paying something like 30 euros a year or something like that. And I get that license for, I think it's 5 or 7 years. And then after 5 or 7 years, I need to renew my license. So I guess I need to do the exam again. But yeah, this depends on the country. In Europe, at least, I think it doesn't really matter where you get your license. You can fly the drone in any other country, but every country has limitations when it comes to where you can fly the drone or not. But you need a license, and you should also get an insurance, right? In case you crash the drone, let's say against a car that is not your car, or a person, that would be horrible. But if you have an insurance, that might take care of all the bad stuff. But also, if you lose or crash your drone, if you have an insurance, you might get paid an X amount of money or even get a new drone back. It is also very important to get a landing pad. So this one that I have here is not huge, but it's good enough for this drone. And once it's folded, it's just like a small circle. And you definitely need a landing pad, right? Especially when working on remote locations, because if the ground when you're trying to land is not firm, the drone is going to complain and it's going to tell you that it doesn't want to land. So you need to kind of grab it with your hands, and that is extremely dangerous. So don't do that, right? And that's very tricky because even if the surface is uneven, the drone can actually take off, but when landing, it's going to complain. So, don't fool yourself like, oh no, I'm fine because the drone has actually taken off. But when you're bringing the drone back home, that's when it's going to complain. So yeah, always have a landing pad, especially if you're shooting in sand or in the forest where you have leaves and rocks and all of that. It is actually important. And this costs, nothing on Amazon. And of course, you need a lot of extra propellers. And this, of course, depends on where you're flying the drone. But if you're flying in a forest, 100% you're going to break a propeller. And when you break a propeller, the drone is going to fly, it's not going to fly properly, basically. Even if you just dent a little bit the propeller, you can see that the drone doesn't balance itself as it should. So you definitely need some extra propellers. Okay, so that's pretty much it. Well, here I also have filters for my lens. That's actually very important. Again, if possible, try to shoot always in an overcast lighting conditions, but of course that's not possible all the time. So here I have like 1, 2, 3, 4 different ND filters that can help you to save your highlights. Okay. Let me check. Oops, didn't want to do that. Software. Okay, let's talk a little bit about software. We can divide this into different sections: acquisition software and processing software. So when I say acquisition, I basically mean software that can help you to plan your flight missions, to make everything automatic for you, so you don't need to fly the drone automatically. This is extremely important for photogrammetry and for survey. You do not want to fly the drone manually. Only when any given conditions forces you to fly the drone manually. Again, 80% of the time or even 90% of the time, you're going to be flying the drone automatically. For that, as I mentioned before, you need to be able to access to the SDK of your drone. Okay, cool. There are multiple acquisition software: DJI Pilot, DJI Fly. These are the apps from DJI that you should have in your phone. They work both with Android and iPhone. You can do certain automations in those apps, but honestly, they are terrible and they do not offer the features that you actually want as a professional drone mapper, right? Or someone who uses the drone for surveying in general. So yeah, don't even think that you can use these applications for professional purposes. Another one is Map Pilot Pro. Another one is pics for the capture, drone deploy, drone link, and UGCS. You know, open a browser, Google, take a look at these, and whatever you think suits you, use that. I mean, they are all very similar to each other. They are all paid applications. I think Map Pilot Pro is the cheaper one, as I believe. My recommendation is UGCS. This one is the one that I like the most. Drone deploy, drone link, and pics for the capture. I've used them also. They are all pretty good. I mean, all of them are valid. UGCS is the one that I like the most, but that is just a personal preference. They are not cheap. Okay, this software I think costs something around $240 or $250 a month. So it's a subscription. The good thing is, of course, you don't need to pay for it all year, unless you work all year scanning stuff. So I only rent it when I need it, but it is by far the best application in my opinion. It's extremely useful to use. Everything lives in the cloud. You can do everything from the browser. It works great with all the drones that have SDK capabilities. In my opinion, it's the best. But take a look around, and whatever you think is the best, use that one. This one here, called Waypoint Map, this is the hack that I was telling you for drones that don't have an SDK. In DJI Pilot and DJI Fly, you can actually use what it's called waypoints. So a waypoint is basically telling the drone, this is an environment. I want you to fly from here to here to here, then to here to here to here, and back home, right? You can do that with a DJI application, but you cannot tell the drone, oh, I want you to do that, but then I want you to do this, and then do that, and then do this, and then do that, and every 10 meters stop and take an action, take a photo, shoot a video, or do whatever you want. You cannot do that kind of thing, which is what you can or want to do with all these other applications. And all those applications allow you to do that and way more things, right? That's the good thing about those applications. You can customize pretty much anything, like the angle of the camera, the resolution that you want to use. If you want to change the angle of the camera between the different positions, you can do many other things, right? With these apps, you cannot do much. So there is a guy who made a web application called Waypoint Map. And it hacks, again, between quotation marks, it hacks this app. So you can actually create a waypoint inside of the official app. Then you create an alternative waypoint using this web application. And then you exchange the file that was created here with the file that was created there. And when you open the app again, it shows you what you created here. So it kind of tricks the drone to do things that the app doesn't allow you to do. So it is great. What is the downside? Well, the downside is it's not as good as any other of these third applications. But given that the alternative is not being able to fly the drone automatically, this is great. I've been using this application for a few weeks now, because this was actually released, I think, like a month ago or something, or a month and a half ago. So it's pretty brand new. And I've been using it for 3 weeks now, and it works for me. Again, I'm missing a lot of features from UGCS, but this one works great for what it is. And this one costs, I think, like $15, I believe, a month. Same thing, it's a subscription, so use it when you need it. I'm going to use it now for like 3 months, I believe, and then I will stop my subscription, right? Because I'm not going to use the drone probably for another 6 months. I'll show you how to use it later. Okay, that's going to be part of this video. I'm going to show you how to use it later, because again, I'm going to be using my DJI Mavic 3 Pro. All right, so I'll show you how to use this. Maybe in future videos. The thing is, I have a DJI Mini 3 that has access to SDK, and I have a DJI Mavic 2 Pro that also have access to the SDK, so I could use any of these applications. The problem is I do not have with me right now the DJI Mavic 3 Mini, and the DJI Mavic 2 Pro that I have with me, I just realized the other day that the batteries are completely dead. And that's because I haven't used that drone for more than a year, because I've been using the Mavic 3 Pro. So I need a way to revive those batteries, but I don't really have the knowledge because I need some kind of electronic magic to fix that, or buy new batteries. But anyway, once I have those drones available, I might have another video. I might have to record another video using UGCS. Cool. But yeah, in this video, we're going to be looking at waypoint map web application, which is pretty good. And then for processing, of course, you know the usual suspects: Agisoft Metashape and Reality Capture. These are the ones that we're going to be using today. But you should also know that there are other applications, and maybe in visual effects we are used to use Agisoft Metashape and Reality Capture because they are very popular for photogrammetry in general. But you will see a lot of people that work on set that use other applications that are way faster and way easier to use, like Open Drone Map, Drone Deploy, DJI Terra, even Pix 4D has a processing section. And I think Drone Link or Drone Deploy also have a processing section. And those are also great. I don't tend to use those because I'm very comfortable with Metashape and Reality Capture. And for the type of work that I do, those softwares seem to be a really good solution for me. But keep in mind that there are other software there that is not targeted for visual effects. It's more for drone mapping in general, but it's also pretty good. Okay, so remember that I mentioned before about RTK, or real-time kinematics. All right, let me have a sip of my coffee. And again, we are not going to use these on this course because this requires extra hardware that I do not own, and I'm not going to rent it for this video. Again, if at some point my Patreon has enough subscribers and I can afford or justify renting this equipment, I will do it and I will show it to you. Also, I think I could make like a full course on RTK, or real-time kinematics. I mean, for sure I could record probably like a 5 or 6 hour video only about real-time kinematics, maybe in the future. For now, I just want to mention it to you because there are high chances, there is a high probability that if you work on set for a movie, someone from the production side is going to ask you to deliver RTK data from your scans. Okay? All right. So let me start by saying that sometimes capturing pretty images is not enough. Okay? So when you're outside capturing data, capturing pretty images, it's not enough. We also need extra data. Like in this case, we need to scan geographically accurate. What I mean by that is like, if this is an environment, top view, and there is a huge rock here, maybe your job is just to scan the rock because we just need that rock to do it in CG. Fine. But maybe you need to know exactly where this rock is located in terms of GPS coordinates, and inside of this, in the context of this environment, where is it exactly? And you want to know that with almost pixel accuracy. Well, pixel accuracy is a little bit exaggerated, but maybe with a margin of error of 3 centimeters. Because maybe the production department needs to build something there, needs to rent a helicopter, or maybe needs to rent a motion control system or whatever. And, you need to do a technical pre-visualization and you need exact measurements. A traditional or a classic photogrammetry scan doesn't give you that. You need to capture extra data. And you can do that with real-time kinematics. So RTK will allow you to correct the GPS information in your drone and create scans with centimeter level accuracy. That's what it means, right? It's going to give you a nice scan, but also it's going to give you all the measurement and all the information of position, location, etc. with centimeter level accuracy, which is great. This is something that is always required in other fields. You know, in entertainment, it's not that important, except when it is, for whatever reason. But if you are a drone pilot working in agriculture, working on engineering, working on landscape development, construction, 100% of the time you need to use real-time kinematics, okay? Cool. So how does it work? It needs two main components. First, the base station, also called the receiver. We place that on a known position. It never moves, and it is constantly sending out its position to the GNSS satellites. GNSS stands for Global Navigation Satellite System. All right, so let me draw something here. Again, this is a huge terrain. Let's say this is 2 kilometers by 4 kilometers, whatever. So we need a base station or receiver. So we would take our base station and we would place it, let's say, here. Okay, so this is our base station. This base station is sending the GPS location of itself, real-time, non-stop, constantly, to satellites, right? We have a huge network of satellites that is part of the Global Navigation Satellite System. So this is constantly sending the position to those satellites. So it's extremely accurate, right? And then we need a rover. And a rover is another station, like this one, that is also sending its position to the satellites. But this one is actually moving. This one was always static. Then we have another one, another base, that is also sending all the information to the satellites. But this one is moving around, and it's moving around because it's mounted on top of the drone. That is that rover, that station that is sending out its position to the satellites. Not only that, but this rover and this base station, they are also talking to each other, right? The rover and the base are connected all the time to each other. And they can be connected to each other using internet, using Bluetooth, using radio, even using cable. Of course, maybe for a drone and a base doesn't make a lot of sense to connect them with cable, but it also depends on what you're doing with it. But they are talking to each other all the time, all right? So we have this guy sending information to the satellites, this guy sending information to the satellites, and this guy talking to this one all the time. All that information gets computed, and it gets translated to some kind of coordinates that then we can use in the processing software to create scan that is not something that looks nice, but it has geographically accurate information to centimeter level, right? So with this system, you get something that with a margin of error of 2, maybe 3 centimeters, which is great, right? That's what you usually use in engineering and construction. Again, we're not doing this because we need extra equipment, but I would love to show you how to do this. And there are many occasions in visual effects where you might have to use this kind of surveying. All right. And also you might need multiple base stations, multiple of these stations that don't move, depending on the area that you need to cover. Meaning that if you're doing something that is really big, you might need to position multiple stations in different parts of the terrain, and all of them would be, again, sending data to the satellites and talking with the drone. Okay, cool. What do you need in terms of equipment? Well, you need your base, right? Or multiple bases. You need a rover. That is this RTK module that you put on top of your drone. So there are drones like this one, like the Evo 2 Pro RTK. That's what it's called, RTK, and the DJI Matrice 350 RTK. So they come with that already. The Mavic 3 Enterprise, which is this one, doesn't come with it, but you can buy it and put it on top, right? Or you can actually buy a combo that comes already with it. Okay, cool. And here I have a couple of pictures of that. So yeah, this is the Mavic 3 Enterprise with the RTK module on top. And these are the different type of base stations, all right? DJI, they sell their own stations, but you don't have to use DJI stations if you use a DJI drone. You can buy whatever brand that sells this type of equipment, right? So yeah, they usually have a post, like some kind of pole, which usually you can put on the terrain, even though I don't really recommend that. It's usually the ones, better the ones that come with a tripod base. You place them somewhere, and this is, all the tech is here. And this is like a diagram of kind of what I explained before, right? You have the base station, you have the rover, and then you have the satellites, and everything is talking to everything. All right, great. Again, this is a fantastic system. This is required in pretty much any industry that cares about data, and it might be required sometimes also in the entertainment industry, like film and visual effects, and especially when you actually need to do a very high-end tech base and you're planning to use helicopters or some kind of construction or something a little bit more technical. So again, it's not extremely common to have to use RTK, but it's not rare either. So I just wanted you to be aware of the system and just wanted to let you know that this exists. From here, look for information online. Again, this is a whole topic. I could, spend like 5 hours talking about this, but we're not going to see any more things about RTK in this video. All right. This is actually important because we're not going to use the hardware for ground control points, but I'm going to show you how to process the data for ground control points. What is ground control points? So if you don't have RTK systems, you want to use ground control points, which is an alternative for real-time kinematics. It's also pretty good, and it will also give you very good information, but you need to do some extra work. So ground control points are marks on the ground that have a known geographical location. All right. So we have a top view of the land, the terrain that we want to scan. We will put a ground control point there, another ground control point there, another one here, another one there, another one there, another one there, and maybe we put another one here, and here, and here, and maybe here, maybe there, there, and there. All right, so we have a few ground control points. So each of these needs to have a known geographical location. What do I mean by that? Well, it's not just about placing the points or the marks on the ground. You need to come with surveying equipment to measure each of these individually. You need to measure those and check the exact GPS coordinates of each of these. So of course you need extra hardware for that. You can use these type of bases as well, and there are other surveying equipment that you can use for it. Usually when you see like people on the streets with these fancy tripods and looking into small screens, like construction people, they are usually doing this kind of thing. So you need that hardware. That's why we're not using these on set, okay? Because I don't have the hardware and I'm not going to rent it for this video. But I'm going to show you how to handle the data, okay? Because I'm going to use data sets that I had from previous jobs with ground control points. These ground control points help you to enhance the position and accuracy of the data. Kind of the same thing that we talked before, right? If you have the GPS coordinates of multiple points in the location where you're scanning, then you can use all of that to create something that is way more accurate. These marks on the ground must use the same EPSG code. That stands for European Petroleum Survey Group. And as far as I understood, even if this has a European word before, this is used worldwide, right? Even in America and well, actually, I don't know about Australia or New Zealand, but in the US and Canada and North America in general, Mexico as well, I believe these codes are used as well, right? So don't get fooled here because the word says European. I think this is kind of like a global system. You would have to use a minimum of 5 marks. I wouldn't say the more the better, but at least you need to use 5. But this also depends on how big is your terrain. The minimum size of those marks needs to be 60 by 60. So these are usually some kind of squares that you buy. They need to be at least 60 by 60. And the reason being is that, the drone, we need 2 things here. One, we need to measure each of these marks, as I told you before, with surveying systems. But we also need the drone to look at this, to be able to see this. So if you have a drone flying, like 200 meters high, of course you need to be able to see this X here. So the bigger the mark, the better for the drone. And as I was saying before, the exact center of each ground control point must be exactly measured, typically by using precision survey equipment like a GNSS receiver, this thing here, or other similar tools. Okay, so basically we would place this thing right in the middle of this X, and it will measure the GPS coordinates. Okay, great. In terms of equipment, what do you need? Well, you need a drone capable of flying automated missions. If the drone is not capable of flying automated missions, this system doesn't work. You need the ground control aerial targets, these things, right? And then you need measurement instruments like a GNSS receiver or similar. Again, I'm not going to show you how to use this on set, but I will show you how to process all this data in either AGISA photoscan or reality capture. Great. Here you can see how this is being used. So here you have the terrain that we're scanning, and you can see that we have placed here multiple of these ground control points, and each of them will be measured like this, right? So here we have a GNSS receiver measuring the ground control point from the very center, and it will give you the GPS coordinates of this guy. So then we will end up with GPS coordinates for each of these, all right? And those GPS coordinates, they end up in a text file, which is this, right? So we'll give you latitude, longitude, and height for each of the points, right? So if we have 9, this is the first point, second, third, and so on. Okay. Yeah, and this is just like a couple of ground control points that you can find in the market. They are not cheap, right? They cost maybe around $60 to $80 each. So they are not that cheap. You can actually make your own, and I made my own, but they tend not to be the best. So yeah, you might need to buy some of these. They have holes here on the corners. So, if it's a little bit windy, you can just, use some camping hooks to place them on the ground, and that's it. And as you can see here, this is a 400 zoom from the drone, but the drone should be able to see these ground control points easily. Okay, great. Another way of capturing information, again, photogrammetry is about capturing pretty images to create nice 3D models and textures, but as you can see, we also need extra data. The best way of capturing extra data is with RTK systems. If that is not an option, global control points. If that is not an option, georeference, that is your friend. And the good thing about georeferences is that you don't really need extra equipment, so it's cheaper, but of course do not expect the same level of accuracy than ground control points or RTK. For most of the things that we do, we are fine with georeferences. Okay, we're fine with georeferences. Again, if you're working on something more complex like construction, agriculture, engineering, working on roads and motorways, that kind of thing, you would never use only georeferences. You would have to use ground control points and most of the time RTK. But in film, most of the time we're good with georeferences, and ground control points is also very common, but most of the time we use georeferences. So georeferences also help you to situate the scan in the world map and real location, but it only uses the GPS that the drone can actually encapsulate in the metadata of the photos. So it's not that great, but it's better than nothing. And actually I will show you later in one of the exercises the difference between using georeferences and using nothing, just photos with no extra information, just pixels, right? And you will see that is a huge difference. It helps to better align the photos. This is what I'm talking about. You will see that later in reality capture. Reality capture will have a very hard time aligning photos that don't have georeference metadata or ground control points or RTK. It will be very hard, and I have a data set with no information rather than just pixels, so you can actually see the impact of not having extra information. And it also helps to avoid the banana effect. This is very important because when you're shooting something that is flat, and a terrain, this terrain is not flat. It has, hills and bumps and roads and whatnot. But when you're flying a drone 100 meters or 200 meters high, it kind of looks flat, right? Because there is no parallax. And you're going to end up with, if this is your flat terrain, or might have a little bit of bumpiness or whatever, your drone scan is going to end up like this. This is what we call banana effect, because the drone doesn't really know, because it cannot see the parallax. It doesn't really know if this was bumpy or completely flat, so it creates something weird like that. When you have georeferences, it will help you to fix that. Another way of fixing that is by changing a little bit your shooting pattern. We're going to talk about shooting pattern next. For georeferences, the only equipment that you need is a drone with GPS. All the drones that we discussed before, right? All these drones should have GPS, so you're good. But if you have a pretty crappy drone, most likely it wouldn't have a GPS, or it would have a really bad GPS. And also you need a processing software that is capable of reading GPS metadata. Okay, and I'll show you later how to use all of this, right? I'm just explaining everything. I'll show you how to use ground control points, and I'll show you how to use georeferences later. Okay, great. We're almost done with the slides. We're going to be talking now a little bit about shooting patterns. Okay, let's finish these slides. We have only 2, 3, 4, 5, 6 left, and this is actually going to be super fast. All right, so when it comes to shooting patterns, we have discussed in previous videos quite a lot about shooting patterns. And I would say everything that we discussed before applies also to drone photogrammetry. The only difference is like what we're doing now, it's bigger, right? In terms of size and in terms of probably, no, I wouldn't say amount of photos actually, because, when we're doing something like a big rock with a camera, with a handheld camera, we take like 500 photos or something. So no, it's not, we don't make more photos with a drone. We might make more photos with a drone when we're doing like a land, like a terrain, like a, big landscape. But, most of the time, I don't think we make more photos, but we take photos of larger subjects, right? All right, so let's start talking about turntables for large assets. So imagine that you have this rock, what is this, like a rock formation, whatever, monolith, whatever you want to call it, and you have access all around these. I wouldn't say this is extremely common, but it can happen. Like in the middle of the desert, you have something that you want to capture, or in the middle of the mountain. If you can approach it like a 360, like a turntable, that's what I would do, right? So 360, just move around the object, and you will do this with the drone, of course. So yeah, 360 coverage. You would use multiple heights and 2 or 3 rounds closer and farther away from the subject based on the distance, right? So as you can see, I have these brown cameras. So each of these is a 360 around the object at different heights, right? And I do that, and then I do another 360 closer to the object. Like, in the brown, with the brown cameras here, I will be capturing the whole object. And maybe from these green circles, I wouldn't be capturing the whole thing, but just, maybe like a section. But that's fine because I covered already the whole thing with the other pass. So I would do like 1, 2, 3, 4 heights. Then I will move the drone closer, and I will do another 3 or 4 heights, but from a closer distance to get more details. And generally speaking, I would be pointing the camera straight to the subject, as you can see in all of these. But when I go to the top row here and here, I would be pointing the camera a little bit down, like I don't know, 12 angle degree or something like that. So I will capture, because otherwise, if I point this camera forward, I wouldn't be capturing anything, right? So you point it down, and you will capture the top. Okay. I also wrote here that you might need top coverage. That depends on the subject. Let's say you're scanning a huge truck that is parked on the motorway, right? So you would have a huge truck. So this is, I don't know, the load, right? Something like that. And here we would have the cabin of the truck. Maybe you do a 360 approach, but then you might do like a top-down approach as well to capture maybe, all of this. So you might combine the 360 with a top-down approach. And all of these can be automated with a third-party application. So you don't need to do anything. Basically, you program everything in advance. You send that data to the drone, and the drone takes care of everything, like flying around this 360, then this 360 moving to different heights, and when it goes to the top, it points the camera down, and all of that is done automatically. You just need to program it before, and then you don't need to do anything. You just need to wait there while the drone is doing the job. All right. Another shooting pattern is vertical elements. We talked about all of these common cases in the first slide of this video, right? So vertical elements are usually buildings, or more than buildings, I would say facades, right? Because if it's a building in the middle of nowhere, so this is a land, and you have a house in the middle, you can do the 360 approach, right? You can just move around. But if it's a building in a city or a set, you might have another building on the side, so then you cannot do a 360. You will scan the facade. And the facade, for scanning facades, you will use what we call a vertical approach, which is this, right? You have multiple heights. The drone is moving up and down vertically. So yeah, the drone will start here, and it will move all the way up, and it will take a picture whatever you actually decide, every 3 meters, every 5 meters, every 10 meters, whatever is the coverage that you need. When it goes all the way up, it will move to the right and will descend down, and will take a picture again every X meters. Then we'll move to the right. It will go up again, right, down. So it will follow this pattern. These are screenshots from UGCS. That's the software that I was telling you that is the one that I like the most. And as you can see, you can change a lot of things here: the minimum height, the maximum height, the distance to the facade, the overlap that you want to use between photos, the pattern that you want to use, the maximum speed that you want to use in the drone, the horizontal speed that you want to use in the drone. You can also change the angle of the camera. So you might say take photos completely straight, but maybe when you go to the top, maybe tilt the camera a little bit. Maybe when you are in the background, maybe tilt the camera the other direction. You can do all of that in the drone. And it will also tell you how long it's going to take to capture everything. And it's also going to tell you how many photos it's going to take. And it's going to tell you how many batteries you need to use. Because, if this takes, let's say, 2 hours to scan, which, well, in this case, I don't think it will take 2 hours. But if you decide to take 5,000 pictures, yeah, it will take 2 hours, right? Because it will move very, very, very slow, take a picture, move very slow, take another picture, move very slow, take another picture. So it might take 3 hours to scan this thing. So of course, one battery is not enough. So maybe when the drone is here, the battery dies. So when the battery dies, depending on what you configure in the application, most likely you're gonna say to the application, when the battery dies, fly back home, the drone will land, right? So you land the drone, you change the battery, and then it will continue in that specific point where the battery died. So yeah, using these applications is extremely convenient, and I would say it's a must, right? But for that, you need an SDK drone. Yeah, and you can also, not all the time, but if you want to get extra coverage, you can do 2 passes. You can do 1 pass vertical, and then you can do a pass horizontally. So here, as you can see, this is a church. So you can do a 360 if you want, or you can treat these as 4 different vertical elements, right? So you can do all of these, but you can say, I want to do an extra pass horizontally as well. So, you do the vertical pass. And when that is done, you can say to the drone, now do a horizontal pass. So you actually get way more coverage. It's not always needed. And I would say most of the time, most likely you're not going to have the available time to do it. But if you have the time, do it, because then you're going to end up with a better scan. All right, cool. That's what I wrote here. 2 rounds, 1 vertically, 1 horizontally, when the time allows you to do that. Otherwise, just do a vertical scan. And again, this can be fully automated. So same thing, you program everything in advance, then you go to the set and just let the drone do the job. All right, then we have big environmental assets. And generally speaking, this would be a combination of the turntable approach and the vertical approach. So if you have a mountain like this, of course, there was another mountain here, and well, maybe not that high, right? But here, there was another mountain there, and maybe there was another thing there. So you cannot do a 360 all around, and here it would be something, right in the back. So you cannot fly around, but you can follow the same pattern. But instead of doing a 360, you might do something like 220 or 180 or whatever. So you would take the drone here and start going all the way around till here. And that would be, let's say, to 100 degrees. And then you would do the same, right? You would start here and do another round, and maybe up here, do another round, and maybe up here, down here, and do another round. All right. And then you might want to do some vertical approach as well. So you might place the drone here and say, well, let's go all the way up and then down, and then up again, and then down. So you would combine both. That's what I usually do for this type of natural elements, right? So again, multiple heights in 360 and vertical, pointing the camera forward straight to the subject. And you also want some oblique angles. That's what I was saying before. When you are up here, you might want to shoot straight, or you might want to point the camera down a little bit. And this can be fully automated or semi-automated, right? Sometimes you might not be able to automate everything, and you might have to do maybe 2 automated passes. One is a flying mission that does the 360s or the 200-degree angles, and another one that does the up and down, right? But it can be combined. Here you can see these. We're going to take a look at this data set and this data set. I don't think we're going to look into this one, but these two for sure. We'll take a look later in reality capture. This is a very quick scan. And as you can see, this is only one 360, and it is only one angle. And this is one of those that I say, well, this is a placeholder for LiDAR. I know that I'm going to come here later and do a terrestrial LiDAR that is going to give me a much better scan. But for now, I just need something for previous, or I just need something for TechBiz. So I'm going to do a very quick scan, something that I can do in like 15 minutes. That's what I do, right? And I take maybe 50 images and I get something that is pretty decent. And this is actually a screenshot of something that takes way longer. And as you can see here, I'm following also a vertical approach where, I do all of these. And then I go to this other side of the mountain and I do also all of these, right? Okay. And this is when you want to scan the whole thing. Of course, if the action of the movie takes place here, right? Only in this quadrant, maybe I want to scan the whole mountain, but then if the camera is going to be here looking at there, I would have to do a high resolution scan of only this section, right? Cool. What else do we have here? Terrain and vast areas. All right. So here we follow a grid pattern pointing straight down. So you can see it here. This is the pattern, right? This is what the camera is doing. All right, and the camera is straight pointing down. What I would recommend is doing this, and then if you have time, do another pass, exactly the same flying plan, right? Exactly the same, but with the camera oblique. So instead of being pointing down completely, doing something like that, right? Because we're gonna get more parallax, we're gonna get better information when it comes to height, and we're gonna get rid of the banana effect, right? Because when we're pointing straight down, it doesn't really know the difference in height, but if you're doing an oblique pass, it will know much better, okay? You can see it here, this is a much bigger land, and it's kind of doing the same thing, right? And the same as I mentioned before, if you have the time, I will do also another extra pass in the other direction. So we'll do something like this. But again, if you're doing a big terrain, this might take easily like 3 hours to scan. So only if you have the time. And same thing, this is fully automated with an application like UGCS that is fully automated. And with the approach that I'm going to show you later today, we can also automate all of these, right? We can do with the waypoint application that I'm going to show you later, we can do terrains, we can do 360s. What we cannot do is vertical elements. That application doesn't have yet a way of automating vertical elements, which is a bummer, but it is what it is. Okay. And finally, I think this is the last. Oh no, we have another one. Okay. So I mentioned before that we also use drones for location scouting. So what you need to keep in mind is like we need to shoot a couple of different things. We need to shoot a contextual shot. And again, that is just flying around, looking at the whole environment, looking for roads, for entry points, for the way of accessing the location, just an overview of the whole thing. And then we also need to capture similar shots that the director might have in mind for that location. Even if it's, like a stage shot, like establishing shot where, you see the whole environment, but in a cinematic way, not just flying the drone around, but doing something more cinematic. And consider that you might have to track the footage. Okay. So I think this is a video actually, isn't it? Let me can I get rid of these? Yeah. So this is a video, and as you can see here, I have tracked this drone, so it's perfectly tracked. And the reason being is like, this is some kind of a cinematic shot. Maybe I show this to the director, and maybe the art department already have built some assets. So I can just say, let's imagine that, you know, we want to show this to the director, we want to show it in context, and we say, okay, we know that here we're going to have some kind of military base or some kind of I don't know, some kind of building that we need to add to this shot. Well, if we already have the asset, we can just track the shot quickly. Once the shot is tracked, we can just get the asset, put it there, do some kind of quick lighting, quick integration, maybe using like work in progress textures or even grayscale, whatever. But at least we can see the location with the main 3D asset that we need for that location, even if it's not finished, even if it doesn't have a final composition or anything, at least we can see it in context. This is something that we do all the time. So yeah, consider that, right? You might have to track the footage. And then for placeholders and augment commercial LiDARs that we mentioned before, you know, the same thing that we mentioned before, the way that we scan terrains, the way that we scan big environmental assets or vertical elements or turntables, all of that applies. The only thing is, like, because this is temporary, this is placeholders, we just need less quality, so less photos. So if we want to scan this thing with 2,000 photos, you know, maybe we say, well, let's scan it with only 300 photos, and then we will get something that is good enough, right? Same for augment commercial LiDAR. We use the same shooting patterns as previous subjects. Okay, that's it. So what I want to see with you guys in this video in terms of exercises or you know, work assignments, whatever you want to call it, is how we deal with big 360 assets. That would be buildings, structures, whatever. This is just the location where I'm gonna go to shoot the videos, so I don't forget. We're gonna take a look also at big environmental assets like a mountain to see how we process that in reality capture or Agashop photoscan. We're gonna take a look also at terrain and vast areas using ground control points. Right, I mentioned ground control points and how important they are. So we're going to take a look at that. We're going to take a look at how to process terrain and vast areas using geo-reference information. Also very important. And why not? I don't think this is going to take me a long time, and it's probably a good idea to show it to you. How do we do drone tracking for location scouting? Okay, cool. So in terms of workflow, same as previously explained, meaning that everything that we mentioned before in other videos applies to drone scanning as well. That's something that I'm not going to repeat, okay? You should already be familiar with processing, in general, photogrammetry assets, so I'm not going to explain the same thing all over again. I'm just going to explain specific things related with drone photogrammetry. And the new thing here, it would be ground control points and geo-references and drone tracking, okay? All of these would be new. So yeah, we still have a lot of things to cover in this video. So let's start with. Okay, so before looking at the actual footage of one of the scans that I have prepared for these videos, let's take a look at this website that I have in front of me. As I was saying before, if you have a drone with an SDK, it is very easy to go to any of those software packages that I mentioned before in the PowerPoint slides. Just Google that, take a look at them. They are all great. They have different prices, different type of subscriptions and whatnot. You can use any of them. They are all great. Maybe in the future, if I manage to revive my batteries for the DJI Mavic 2, or as soon as I have my DJI Mavic 3 Mini that I don't currently have with me, maybe I can record another video and I can show you how to use any of those applications, especially UGCS, which is my favorite one. But now I'm stick to my DJI Mavic 3 Pro. That's the only drone that I have available at the moment, and that one doesn't have an SDK, meaning that I cannot use those third application software to map my flight missions to automate the scanning. So instead, I'm going to use this website called waypointmap.com. Okay, and again, I explained this before. With this tool, you can kind of hack the software, the DJI app for your iPhone or Android, and you can automate pretty much everything. You cannot automate, as for now, vertical surfaces, but you can automate terrains and you can automate turntables. So I'm going to be using this one for the scans that I'm going to do for this course. All right, cool. So again, waypointmap.com. You need to log in. You need to create an account. You can use it for free, but it is limited. So for drone scanning, it's actually not great, the free version. I mean, you need to actually pay for a subscription. I believe it's $15 a month, which is very reasonable, I think. And of course, you only pay for it when you use it, right? So, you know, if you're planning to scan a lot, you pay for it for a month, you do your scans, and then you don't have to pay for the next months. Okay, so again, I've been using this website for a few weeks now, and so far is working great for me. Actually, I need to grab my mouse because I only have my Wacom tablet, and it's a little bit funky to work with it. Give me a second. All right, here it is. Of course, I'm not gonna edit this out, so bear with me. Right, so once you log in, you are presented with this, which looks like Google Maps. Actually, it is Google Maps, and you just need to go to the location where you want to scan. So in my case, you need to use Control and the wheel of the mouse to zoom in and out. So I'm in the Stockholm area in Sweden. I'm planning to go somewhere around this national park, and there is a subject that I like. I believe it is here. Is it here? No, actually, it's not there, but it looks very similar. Okay, well, you can actually type here the location and the coordinates, but it should be fairly easy to spot the location. Let me zoom out a little bit because maybe I'm wrong. I'm in the wrong place. I don't think it's that far. Oh man, I'm a little bit blind. I thought it was here. It looks very similar. No, it's not there. All right, let me zoom out a little bit. Oh, here. Okay, so this is the place where I'm gonna go to scan a couple of things. So what I'm planning to scan is this whole terrain here. This thing that is not, you know, this is a huge national park. As you can see, it's a huge forest. It's like 3 times bigger than the city. It's I go there pretty much every weekend with my dog. So of course I'm not interested in the actual forest because everything is covered by trees. So I want to scan this open space here, which is actually quite large. These buildings here, they are barns for cows and horses. It's not active anymore because one of the laws is, at least in Sweden, the regulations is that you cannot fly your drone if there are live animals around. So this is not active, so I can actually fly the drone. And these are huge buildings, right? And this is a road, so you know a person is like smaller than the cursor of my mouse. So this is quite a large terrain. So I'm planning to scan this terrain. That would be one thing, and then and I will be using the grid pattern for that. And then I want to scan this huge structure, which I don't know what it is, but it's quite large. It's made of concrete. And then I want to scan these buildings as well. So yeah, let me show you how I would use this software. So if you scroll down, you have this section here, and this section is what you can use if you have the free version. And then here you can see these premium generation settings. So these are settings that are only available if you have a paid subscription. Okay. Again, this is way limited compared with the other third applications that you can find and that I mentioned before, but you still can do a lot of things. So the first thing that I want to do here is set the altitude of the drone. So this is the altitude in meters that you're going to be using, you're going to be flying. So of course you need to know a little bit of the environment that you're going to scan. In my case, I know this environment very well, and I know there are some trees here. You can see them. I mean, Google satellite photos, they are not that good in Sweden, and that is because it's restricted by the government. So you can actually not get like full 3D view and other things like you can do in other countries. But I know there are a few trees here, and these trees are actually quite tall. They are somewhere around 50 meters tall. So if I fly my drone at 25, I know I'm gonna have issues. Like this first section here, that'd be fine, right? But once the drone goes here, I know that 25 is not enough. So I'm gonna crank these maybe to 60. Of course, you know, you want to fly the drone as low as possible because you're gonna get more resolution, right, out of the photos. But I know this is not possible here, or maybe I can do like an extra scan where I scan everything at 60 meters, but then maybe I do another one in this section where I do maybe like 30 or 25. But in this case, I'm gonna stick to 60. Then you have the speed of the drone, 2.5 meters per second. That's fine, that's what I usually use. Don't go too fast because maybe you can introduce motion blur in your photos, some blurriness and artifacts, and you don't wanna get that. And then you have the gimbal angle. So what I tend to do is I tend to do one scan at -45, which is oblique, like you can see here. And I do another one at -90, so it's pointing straight down. So that would be two different passes that we're going to do. Then you have the distance between paths. So this is the distance between the grid lines that we're going to generate here in a minute. And that is going to give you more or less photos, right? If you use something like only 10 meters, you're going to get way more photos. If you use something like 60 meters, you're going to get less photos, less overlapping, but you need enough overlapping. So I'm going to start with something like 30. Okay. Then here, this option is pretty cool. Dynamically maintain altitude. So this is going to adapt basically to the different heights in the terrain. This looks quite flat from here, but it is not. I mean, there are these huge boulders, and they are maybe like 10 meters in height difference compared with the rest of the ground. So it looks flat, but it is not. So I'm gonna say that it adapts automatically or dynamically to the terrain. Then this is generate points with actions, right? So you only have this in the premium subscription, and it's extremely important because you want to do actions, and the actions that you want to do, you want to take a picture in every waypoint. All right. Reverse points. This is only applicable if you live in Australia or New Zealand, because apparently there are some issues that when you automate the DJI drones in Australia or New Zealand, what might happen is like the drone actually flies backwards. It also works, but sometimes it's annoying. So if you click on reverse flight path, it will fly forward. If you are in this part of the world, you wouldn't have that issue. Then you have line orientation, and this is to create a pattern from east to west or north to south. And then you have straighten flight paths, meaning that it will go completely straight or it will do curves. I like to do it straight. And then you have generate all points, which means that instead of creating just one path or the other, it will create both at the same time, which is what I usually use. Okay, that's everything you need. There is no more options here. So now, once you have all of that set, you come here to this shape drawing tool, and I can say I want to scan this perimeter. Once you're done, click on the hand again, click on the shape, and click on generate. And this is going to generate all the waypoints. And as you can see here, these are all the points that I'm going to generate. So these are 141 waypoints, meaning that we're going to get 141 photos. If you scroll all the way down, it tells you here that the total distance is 15,000 meters. So basically, this is what the drone is going to fly. That's the total distance. It is going to take 105 minutes. And with that, you can calculate how many batteries you might need for this mission plan. Okay, great. That's how you do it. Let me reset or clear this, and I'm going to show you this. If you want more overlapping, if you want more photos, then you will set this one to maybe 10. Right? So I'll set this one to 10. All the other settings remain the same. I do a similar shape. Generate the waypoints again. And this is taking a little bit longer. And that's probably because it's going to generate way more points. There you go. So that would be probably overkilling, right? And sometimes there is an issue. No, now actually it worked. But now you're going to get 973 minutes. So, that's a very long time. So this depends on the purpose of your scan, the quality that you need, and of course, the available time that you have in this location. Okay, great. Let me reset and let me go back to 30. Okay, do the thing again. Okay, great. Generate points, and it's going to generate again 100 and something. Okay, now it was a little bit less than the previous time, but it's probably because I draw like a slightly different shape, a little bit smaller. I think before I was covering this whole area, but you get the point. Once you're happy with that, you scroll all the way down. You need to do something here. Action on mission completion. Basically, you want the drone to return home. And then you need to download the KMZ file. Click there, and this will download this thing called output.kmz. Once I'm happy with this, I will generate exactly the same thing, but at -90, and just save a new one. And that would be 2 different scans. All right? That's how you use this website. Great. Now, I want to scan these buildings. So for that, I'm going to use the turntable shooting pattern. So I'm going to use this circle. I'm going to click. What I want to do here is 3 scans at the same time. I want to scan both at the same time, and then this one and this one. So what I'm going to do is this. I'm going to click on the middle, create this thing, right? You can actually move it if you want. And this is going to fly all around using the settings that you have here. Same thing applies. Gimbal, distance between paths, actions, all points, everything is the same. So now I can just click here, generate, and this is going to do all of these. Okay, so here there are not that many pictures, right? So what you can do if you want more, just reduce this. Okay, but let's pretend this is what I like. Now, I'm gonna do another pass, but in this time I'm gonna get much closer, right? Because these buildings are like 10 meters high or something. So let me do another pass at 20 meters. So I do the same thing, and I generate points. And now, these are kind of overlapping, but they are using different heights. And then I want to scan each of these individually. So I'm going to create another circle here. Generate points. Great. And I'm going to do the same for these other buildings. Generate points. All right. And I was saying before, this sometimes doesn't update. So sometimes you need to refresh the page. So I'm not 100% sure if this is accurate. Otherwise, refresh the page and do it again, and it will tell you the actual truth. All right. But in theory, this will take 46 minutes. Great. Yeah, that's pretty much it. So as you can see here, I'm combining 4 different scans into one single file. And in the previous one, I did 2 separated files, right? So it's up to you the way that you want to handle this. Once I'm happy with this, again, I'm going to go here, download the file, and this has been downloaded here. Okay, great. That's pretty much how you use it. That's pretty much how you use any other software for planning missions. But the other third application software, they usually have way more options. So you can calculate many other things, right? And you can move the camera between one waypoint or another, and you can do a lot of things. You can actually do some of those here as well. Like, for example, if I want to do something specific in this waypoint, I can just click here and I can change the options for that specific waypoint, which is pretty cool, right? All right, great. So that's pretty much it. There is no much that I have to say about this. Once you have these files, what do you do with those files? Well, you need to have a waypoint created in your application, in your DJI application in the phone. Meaning that, if you're doing this for the very first time and you've never done a waypoint in your DJI application in the phone, you need to take the drone out. You need to create a dummy waypoint, and that will save a file in your device, in your phone, right? So if I open an Explorer here and I go to my phone, which is a Pixel 6, and I go into internal storage, here I should have an Android app, data, and here you would have a folder called DJI Go, which is the application that we're using, right? You go inside, you go to files, you go to waypoint, and here you would see all the waypoints in your DJI application, which they usually have this structure here, right? If you're using an iPhone, it's very similar, but of course, it might not be that easy because Apple ecosystem just sucks for some things, right? So that's why I prefer to use an Android device, but it's kind of the same workflow. Then you go to this folder, and here there is a KMC file, and this is the dummy waypoint that I created on my phone. What do I need to do now? Well, I need to go to these files that I downloaded before, right? And you need to basically overwrite this dummy waypoint. So I'm gonna copy that name. I'm gonna replace it here. So this would be exactly the same name. So now I can copy this one here. And oops, I actually use a bad name. There you go. So now I can just copy this one here, replace the existing, and that's it, right? Now you take your drone, you plug your phone, open the DJI app, and this waypoint would be available there. So just click on the waypoint, click on start, and the drone will do everything automatically. The only bad thing is you need dummy waypoints, right? So basically, if you have 2 files like I have here, I would need to create 2 waypoints, or just have this file in my phone or in a laptop or in the location and just do the same operation again. Just copy this name again. I'm going to delete that one, paste it here, do that, copy, replace, and you're good to go. That's basically how you use this waypoint map application. Again, it is not ideal, it is not the best, but it is the only solution that we currently have for drones that don't have an SDK available, like the DJI Mavic 3 or the DJI Mavic 3 Pro or any other drone without SDK. Okay, great. So I'm going to the set and I'm going to do these scans and we can take a look later and see how I process all this stuff. Okay, so we have a lot of data sets here that we can explore, that we can take a look, and we can see how we process them in the best way. Before starting, I actually want to show you the difference between bad data and good data. So I have a folder here called no data, right? And then I have another one here for assets, for ground control points, for georeferences. We're going to take a look at all of those. But I have a folder here called no data. So this is, remember this environment that we were looking at before, right? So I scanned this on purpose with bad data, meaning that the only thing that I have, well, I wouldn't say bad data, but not as good as it could be. For that environment, I didn't use ground control points, I didn't use real-time kinematics, I didn't use georeferences. The only thing that I have for that environment, if I go here and if I go to images, it's, I don't know. Yeah, I have 82 images here. And these are just photos from the drone with no extra data. So let's see what happens when I try to use that in reality capture. So I'm going to open reality capture. I'm going to select all the images, drag and drop here, and I'm going to align these images. So I'm going to go to alignment, align images, and this should take very little, especially because it's going to fail. I can tell you that in advance. There you go. So if you take a look here, only it has created two components. It couldn't align everything, so it's not the best, basically, right? And this is very common when working with drones. And actually, this wasn't that bad. I actually managed to get something there, but it's not ideal. And you'll see this later. Like, once I start introducing ground control points and georeferences, we're gonna get like a perfect alignment. And that's because what I said before, like sometimes scanning is not just taking nice pictures, it's just taking the right data, okay? So keep that in mind. Let me create a new file here. Something worth saying is that Agisoft Metashape, in my opinion, is better for working with drone footage. And again, that's just my opinion, right? If we take all of these here and we try to align these photos, okay, this might take a little bit later, a little bit longer. Agisoft Photoscan tends to be slower than reality capture, especially when using large data sets. But in my opinion, it's more flexible. It's, I know it's considered like an old software, if you will. It's been around for many, many years. I still prefer Agisoft Metashape than reality capture for many things. Okay, the only thing that in my opinion is better about reality capture is that it's faster. Okay, but let's see what we get from here. Ideally, we will get something a little bit better. Okay, I might stop the video for a second. Okay, it actually took only a few more seconds. So as you can see, I didn't get any complaints. I didn't get any misalignments. Everything seems to be working just fine with Agisoft Photoscan. So again, if you are, and actually it's quite flat, we're not getting any banana effect or anything really terrible. So, well, we're not getting image points here, but that's because I didn't cover that, right? Those are the buildings, and I did that in a different scan. So basically, you can see where my flying is starting, right? From here to there, this area is in a different scan. But yeah, you can see here that it worked better than Photoscan. So my point is that having no data, only photos, is not the best, especially when scanning surfaces, like large surfaces, like terrains and big environments. You also need, again, ground control points or georeferences or RTK or whatever is available. But in my opinion, again, Agisoft Metashape does a better job when it comes to drone scans and terrains in general. One solution, of course, in reality capture is to use control points. I showed you how to use control points in previous videos, so please go back and check those videos if you don't know what I'm talking about. But of course, when you are scanning something as large as this environment, it is a pain in the ass to use control points, because basically you need to go photo by photo or every 5 or 10 photos, saying this point in this photo corresponds to that other point in this other photo. So, it's just a time-consuming process. So again, if you can use ground control points, use RTK or use georeferences. And again, I'm going to show you how to deal with this in a video later. But otherwise, Agisoft might give you better results than reality capture. Okay, just keep that in mind. Okay, and another thing that I wanted to show you is that sometimes I also use video for my scans, right? So here I have a video. I don't know if I'm going to be able to play this because it's 4K and I'm recording the screen at the same time, so maybe it runs out of memory. But as you can see here, this is a video that I did. So and this is something that I did manually. So I'm flying the drone manually as slow as I can. In DJI consumer drones, you have this mode called cinematic. So you have cinematic, you have normal, and then you have sports. So if you put it at cinematic, it's going to move as slow as possible. And as you can see, we're not getting artifacts, we're not getting motion blur, so it works quite well. These are the trees that I was mentioning before, so I might be, as you can see, I need to move my drone because I was about to hit a tree. But anyway, I'm just flying the drone manually in this environment, and it is overcast, so it's perfect conditions, right? So again, I usually do this. I fly my drone, I capture a video only if I have time, only after doing all the automated mission plans. And I do this as a backup, right? Because I know that I can use the video just in case something doesn't work in the photos for whatever reason, or I can actually combine the video with the photos. I don't remember if Agisoft, I think Agisoft actually can use a video. And reality capture can also use a video, but it's extremely slow because it needs to extract the frames and it's terrible. So what I would recommend is to use FFmpeg, which is a free software, to extract frames based on the video. And the way you would use it is like this, right? Let me go here. This is where the software is actually, you don't need to install the software, you just need to unzip it. Then you need to open a command line, go there. This is in a different drive, I believe. This is D, so I need to do that, okay? Now I can go there, and here is the software. It's called ffmpeg.exe, and you need to use a line code that I have here for you. So basically, this is what you need to type. So you would use the flag -I, and there is plenty of information in the website about this software. In my video about Gaussian splatting, I also explain how to use this software, but basically you point to this video, so I can just drag and drop here. Great, right? and then I just need to do the flag VF. So this is not going to compress the video or the footage or do anything weird. Then you need to specify the frames that you want to extract. So basically you can, and this is in seconds, so every 0.5 second I want to extract an image. Then you need an output for the path, right? Sorry, a path for the output. So in my case I use this folder, but you can, I guess, create another folder. I'm gonna call this one test. I'm gonna copy that path, okay, paste it there, and then you need this, which is the flag for the padding. So I want to use 4 digits, so you would use again that percentage 04 or 03, whatever, D, and then the format that you want. So let's say JPEG. Hit enter, and this will start exporting the frames. As you can see, I'm exporting those frames here, right? So this would be frame 1, frame 2, frame 3, frame 4. So if you think this is not enough overlapping, you can reduce the 0.5 to, let's say, 1, and then you will get more frames. If you want less frames, you can reduce that to 0.2 or 0.1, and you will get less frames, okay? Great, I'm gonna cancel this, and I'm going to delete this test image, this test folder, because I have already extracted a few of those here, sorry, not there, here. So as you can see, I've extracted some of these frames. Right, so as you can see, might not be enough overlapping, but you know, this was just a test. And I have recorded multiple videos, right? Because these are only 46 images, which is not enough. But this video here only covers one section. So I have like, let's say 8 videos, I think, covering the whole thing. But anyway, once you have that, you know, these are just images, drag them there, align them. I mean, this, of course, is not going to align very well because it's missing a huge portion of the terrain, right? Because that has been recorded in the other videos, but I just want to show you how to use these. There you go. So yeah, some photos fail to align, right? But, you know, it got a few, which makes sense because then, you know, the other stuff is in different videos. But yeah, this is just me saying that if you want to use videos, you can use videos. It's not recommended, but I use it as a backup, right? And again, only if I have the time. Great. So this was just a quick overview of a data set that doesn't have extra data. It only has photos. And I just want to emphasize that it's extremely important to have extra data. And you're gonna see that with other exercises that we're gonna do in this series, where I'm gonna be using ground control points and georeferences, and you will see that those will be solved much better because we have that extra data. Okay, great. What else? What else do we have here? Let me go here and actually place this in the wrong location. But let me show you this. Right? We also had a look at this before in the slides. So this, again, even this has georeferences. Don't worry because we're not going to use them right now. And we're going to use this just as a regular images. And again, this is a scan that was done for previous purposes. So there are only 45 images. This is nothing, right? But again, we don't care that much about the quality of this scan because it's going to be rescanned later using terrestrial LiDAR and maybe more drone scans, but with way more images instead of 45, maybe 300 images or whatever. So we're going to get a much better scan. But I just want to show you that if you have nice pictures, if you have good data, you can get a scan that is decent enough. So I'm going to drag and drop this here. I'm going to align the images. This should go fairly quickly. So let's wait a couple of seconds. There you go. So we have 40 cameras and the 45 of them have been aligned properly. So yeah, you see that things work as expected. This is the flying patterns. As you can see, it's a 360, everything automated. And so yeah, everything looks great here. Everything looks as expected. Let me quickly come here. Let me perhaps, I'm just going to resize the bounding box a little bit because this is the only area that I actually care about. Okay, great. So workflow, mesh model, high detail, and let's reconstruct this in high detail. Shouldn't take long, right? But anyway, I'm gonna pause the video because it's gonna take maybe like 5 minutes or something. Okay, so this is done. The mesh is complete. It took 7 minutes, okay, in my computer. And as you can see here, this is pretty damn good for 45 photos, right? Again, this is great. I mean, we have plenty of detail. And again, you need to judge if a scan is good or not based on how you want to use that scan. In my case, I want to use it for previs and I want to use it for techvis. And that is pretty good. I get everything that I need. You know, all these jagged rocked, everything looks great. Again, I know that later I'm going to come here with terrestrial LiDAR and scan this with, you know, millions of polygons. And I'm going to do another drone scan and I'm going to get something much better. But for the purpose of this scan, this is just perfect, right? So now I'm going to just go to workflow, mesh tool, and I'm going to colorize this. And remember, colorizing is not texturing, right? It's just vertex colors. So basically we're coloring this point cloud, and it's only going to be as good as, well, the source, meaning your photos, and how dense is your mesh, right? Which actually I forgot to check. So we can check that in a minute. I don't think this is gonna take very long. It should take like a couple of minutes. But yeah, let me pause the video and we can continue in a couple of minutes. Okay, actually took 37 seconds. All right, so look at that. This is just great, right? The only thing that is bad here is the lighting conditions, because as you can see, it was a sunset, it was very sunny, and we have shadows. But you know, again, for a work in progress scan, for something that we're going to use for techvis and previs, we can delight it a little bit, and we can you know, fix these textures in Mari. But you know, it's a pretty good scan. So yeah, this is 36.4 million triangles. So it's actually pretty good. And that's it. That's what we get, right? So a really nice turntable, pattern shoot, automated, and with only 45 images, we get a pretty good scan. One thing that I should say that I didn't mention before, you know, if you're not familiar with alignment settings, if you're not familiar with meshing settings or colorizing or texturing, please go back to all my other videos, okay? I'm not going to explain all of that again because I've explained that previously many times. So again, if this is the first time that you're watching this video, or well, not this video, my series of videos about photogrammetry, please go back and watch the other videos because I'm not going to explain the same things again. Right, so from here, we have a pretty valid scan. Of course, now we need to clean this up. We need to take it to Maya or Blender or Houdini or whatever. We need to clean it. We need to remesh it. We need to do proper good UV mapping. Then bring it back and reproject all the data here. Displacement maps, normal maps, albedo, and whatever you need. Again, that process, I'm not going to explain it to you. That process, of course, takes time. It will take me a couple of hours to do all of that. And I've shown you how to do that before with more than one asset. Okay, so again, go back to those videos and check the full workflow. Check the entire process. I'm not going to explain that again. Okay, so yeah, this is great. This is fantastic. Cool. Oh, and by the way, this is also important that I forgot to mention it. When I said before that, a scan should have georeferences, it should have RTK or ground control points. All of that is extremely important if you actually need to provide extra data to the production. If you only care about nice images, you saw in the previous example that is also important for terrains, but it's not that important for turntables. And the reason being that in turntables, we actually have more information of height, we have more information of parallax, we have way more information in the actual photos that we can actually produce a very nice scan, as you can see here, even if we don't have that extra information. That extra information is only important for terrains, okay? And again, for the production, if they need extra data about measurements. But for actually creating a 3D model and nice textures, we don't need that extra data for turntables, as you can see here. This is a perfectly valid scan with no extra data. Okay, great. Let's take a look now at the other turntable example that I have here for you. And that would be, I think it's in assets. And I think it's dataset 3. There you go. Images. And we can use, let's use JPEG just because they are lighter, right? And these are 214 images. These are the buildings, right? The buildings that I showed you before that I wanted to scan using a turntable. So as you can see here, this is one of the photos where I'm scanning everything at the same time. And then there are more photos for this complex of buildings here and this massive structure there, all right? So I'm gonna select everything, drag and drop. We have 414 images, I believe, right? Is that what I said? 414, there you go. So let's go and align all of these. This is gonna take a little bit longer, but it shouldn't take that long. So, okay, great. This took about 8 minutes. And as you can see, here we have the flying patterns that we established in waypointmap.com. We actually don't care about all this extra data because we have it in a different scan. What we have here is just the buildings, and well, we have a little bit of terrain that we can keep there because then it's going to be easier to blend with the other scan. But yeah, I mean, you can see that 214 of 214 cameras have been aligned, so massive success, right? So out of these, we're gonna get a very nice model. The only downside is like when I took these photos, when I did this scan, the first 3 hours when I was in this location, it was perfectly cloudy. Like everything, it was a very nice overcast day, so I got a very nice scan of the terrain. But unfortunately, this was at the end of the day, and there was a sunset, and we have some shadows, like very long shadows on the buildings and stuff. But, we just need to live with that. Okay, great. From here, kind of the same thing. Create a high-resolution model, create a coloring so we can actually see the colors, and then take that out of a reality capture, create your nice geometry, your very high resolution UV mapping, bring that back and reproject everything, right? So I think here I should have everything, this data set in particular. I have processed this by myself already. This took a little bit longer, right? Because it's 214 high resolution image. But as you can see here, this looks pretty damn cool. Again, we have the issue of the shadows, as you can see there. But yeah, this looks pretty good, right? This looks pretty decent. Let's see if this loads. Well, it's loading slowly, but it's loading. So as you can see, this looks pretty good. It's trying to load the textures. Again, I'm using the GPU to record the video, so of course takes longer than usual. But as you can see, it's trying to load all the quadrants and everything. But yeah, this looks pretty good. One thing that I that I'm going to actually explain, because again, I'm not going to repeat alignment settings, geometry settings, the process of taking this back to another software and do remeshing and good UV mapping and all of that. I'm not going to repeat that because I've done it already. But one thing that I actually going to show you in one of the sections of this video is to get a terrain like the one that we have here, which is quite big, and how to do that process, right? Because when you need to do what I'm saying, like exporting the model from here, taking it to Maya or Blender or Houdini, whatever, remesh it, do a nice UV mapping, bring it back and do the reprojections. That is easy when you're scanning a prop or when you're scanning a fruit or a weapon or, whatever. But when you're dealing with huge terrains, and maybe this terrain is 700 million polygons and that kind of thing, that is actually quite difficult. The only way that I handle that is inside of Houdini with some procedural tools. So actually, I will show you how to do that, okay? Because that's something new in this course. And that only applies to drones and LiDAR scans and, something that is extremely heavy in terms of geometry. So I will show you how to do that in Houdini. I'll show you my workflow. We might create a couple of tools to do that. Everything, with HDAs and wranglers and that kind of thing. Something simple but effective, and I use that all the time. But yeah, you can see this turned out very well. And again, the purpose of this scan is not even the terrain, right? It's just the buildings and the huge structure over there. And of course, this is not a high resolution scan for this, right? Like I mean, you cannot do like a close-up shot of this structure, right? To do that, of course, you will come here with a handheld camera, with a DSLR camera with cross polarization, and you will scan this properly from the ground. Or, even better if you have a LiDAR. You know how to do that already because I showed you in the first videos. But yeah, for a drone scan, this is, I believe, pretty good. And yeah, we can use this in our environments. Okay, great. I think I'm going to stop the video here because, this is taking longer than I expected. There would be a part 5 or a second video about drone scanning, and we still need a lot of time to cover what I want to cover. I want to cover everything that is new, basically. So I want to cover also another data set of a huge mountain that combines 360 turntable and vertical scanning. I want to cover ground control points for terrains. I want to cover also georeferences for terrains. Then I will show you my workflow for processing those huge data sets in Houdini. So we can remesh it, we can create very nice UV mapping and bring it back to reality capture or Agisoft. It doesn't really matter, that is exactly the same process. And reproject all the detail again, and with those nice UV mapping. And after that, I think I'm gonna show you quickly how I usually do drone tracking for my shots when I do location scouting. And I think that would be the next video, which it will take also another couple of hours at least. Okay, great. So let's stop it here. Hopefully you are enjoying this video. Hopefully you're learning a little bit, and hopefully